same like last time the Singapore guy bring on the same deal rate?
Yeah.
This one the older model, no?
No, this one uses.
Oh,
the new model can use the.
That's why I want.
Unity Pro or authorized.
Last time you have one plan bring older model, same model like this, but
It's a 580 maybe. This one is a
180, the one is higher than this one.
Yeah.
this one I try to because he use
That one is using
Unity
Unity Pro.
Pro older version
Oh, yeah.
that only compatible with Windows XP. I tried to connect, can't able to connect, then I have to give it back to him. I don't know what was the issue. So
I think especially for M340 and 580s need to use the one contract step.
That one is a TS model.
Older model.
Anyway, okay, my name is Yogi Swaran, I am the manager, training organizer. This is your trainer, Mr. Divian. Okay, I just need your full name according to IC and IC number and your email address. This one to prepare attendance and certificate. Yeah, the certificate I will prepare. I will give it to you on the third day of the training. The hard copy I will pass it to you. Soft copy I will give it to you.
Okay. Also the training material.
Training material is right over there. The hard copy of the manual. You want to grab the soft copy should be in the laptop. Yeah. Oh, that's right. I can just type it.
So full name.
Full name, IC, and then email address. Malaysia, right?
Yeah.
Okay. So I'll just give a quick introduction. We have two company names, AS Automation Services and AS Automation System Training Centre PLT. This company was established in 2012. We kickstart as specialized in troubleshooting PLC, HMI, and we do involve in project. My boss, Mr. Sundrason, he opened up his company. His background, he was an ex-army under TUDN, Kedah, and he was a technician. He was a technician that served under TUDM, and after he completed his service, he's from Kedah, so he now he's 75 years old. He's retired due to his health condition. So in 1990s time, he came down here to look for a job in Singapore. At that time, Singapore was booming, and then he did his diploma in industrial automation in Nanyang Poly, and he already he did his degree in instrumentation engineering under Royal Australian Air Force. And then he did his diploma in industrial automation here in Singapore, Nanyang Poly. Then after that, he pursued his career in PLC. I become interested, passionate about PLC. The first PLC in touch was the older model, S5 PLCs, Siemens. Because here in AS Automation Services, we not only focus on Schneider, we also focus on Siemens. Siemens got two types, S1200 and S1300 PLC. Both also using different software. Also, even S7200 and S7300 can use PI Portal, the new software. And then on-road PLCs, also we have two types, C series and NX series. C series using CX1 and NX series using Sysmex Studio. And then Mitsubishi GXWorks 3 or GXWorks 2. And then Allen Bradley PLCs, which is not on the board over there, which is on the rack here. It's on the rack over there. So the one using RS Logic 5000 or no RS Logic 500 software. And then the less demanding one like Kians, Schneider, Beckhoff, GE Varnuk.
You guys familiar with T-Box?
T-Box.
Yeah. Have you heard it?
Heard about T-Box?
Because,
There are about thousands of PLC brands over there, yeah.
Because in my plant we are using T-Box. It's like a Belgium brand.
Oh, Belgium brand. Okay.
But right now we are currently transitioning into Schneider.
Schneider. Easy to get suppliers.
Yeah, T-Box is very. I think in Malaysia only the authorized seller is
Okay, so in 2012, his introduction is company profile as well. He collaborated with a German company because we have another AS Automation Services DE in Singapore, but that one mainly focus on project and consultation and services. We time to time we do project, but our main focus here in Malaysia is training. And then in 2014 we registered ourselves as the HRDCorp Malaysia as a license training provider. Since then until now we have trained more than 3,600 plus, almost 4K already participant. Not only Malaysian, we used to train some foreigners. I don't know how they find us. So Indonesia used to be our major customer, and Singapore as usual. And we had clients from Libya, even Matsari also used to show up one Scottish guy. He was doing some project in Singapore. He came down here last year. So we used to get all these clients. Okay, so yeah. In 2021, my boss had to retire, so Kivian take over. Kivian joined here in 2015. He's a mechanical engineering background and now shift as a automation engineer already. And he did his studies in UTM as well. And now working as a trainer with us since then. Okay, so yeah, I don't want to waste too much time. So I let him start the training first. So at the end of the training, like I said, certificate will be provided. Okay. So water bottle you need water, swings all arrive over there. If you want to grab a coffee, 3-in-1, coffee, black coffee, tea, all prepared over there with a hot water dispenser as well. Washroom is straight, you right. Okay.
Thank you.
So yeah. Yeah.
So I will be using this.
Yeah.
Mr. Tivian, yes, I will gonna give your.
Yes. No problem. Later we can write this one. So this is the power supply. This one is the 340 more plus internet. This one is the RS232.
I just bring them in case.
Okay, then this one. But you didn't bring any digital I/O lah. Okay.
Actually,
This one is yeah. UI is a good.
maybe we can try
Upload the program. Yeah, simulate, yeah, of course. The input output and simulate. So this one is a 24 DC, right?
Yeah.
24 DC. USB or bus. Because this model very rare to use.
Yeah.
I know how to do it because all PLC same.
Just
Programming is same because this one the programming way is because they use what they call IEC 66011-3 they are formatting. So this one and back off, okay, and just now you said keybox, just now I see they also using the same type of programming.
Yeah.
Alright, no problem. So okay, now your background is
Mechatronic.
mechatronic. So you learned PLC before?
Yeah, I learned before, but not really deep into.
What PLC?
Omron.
Omron, this
Yeah.
type. Okay.
Yeah.
Then this Schneider, have you touched the Schneider before?
I've touched before, because this is the one that installed this PLC is our contractor.
Okay.
So that's why I'm still not very familiar with this PLC.
Okay. But you know how to use the software, is it?
It's just
Basic lah.
Basic lah.
Okay.
Like
Backup, upload, download. Okay. Start from the basic lah. So you Jetama is from Sabah. Oh.
Yeah. Actually, we are plant water operators.
Okay.
We operate water treatment plant.
Oh, water treatment plant lah. Okay. Sabah.
Water operators.
Sabah where?
KK.
See last week.
You've been to KK before?
Yeah. Last time we went to Sepang.
Oh.
Where 8 packs. So they asked us to come there, so we go
Oh,
there.
yeah,
And after
because-
that, actually last week also there's one guy from actually Labuan lah. He's working for Petronas. So he come for training last week. And I got a lot of students from Sabah actually. Actually next week also one guy from Sabah. Actually 4 packs for Siemens. So 3 packs are from here, KL company. And one guy is a personal, he's from Sabah. He's coming, join the team.
What company?
No, he's personal.
Oh, personal.
Personal. Actually, he last year he attended for Omron training.
So it's
And this time he want to learn the Siemens. Okay. So we just start with the basic first lah. Okay. Because for me, I think it will be easier because you say you know the basics of PLC, right?
Yeah.
Okay. So we go to Schneider. Okay. Just give a slide. Okay. So you know what is PLC, right?
Yeah.
Very simple. Actually, there's a lot of brands. Like you say, the T-box. First time I heard T-box. I never heard before. Actually, I know more than for me lah. If you ask me, I know more than like around 15 to 20 brands lah.
Yeah.
of
Actually,
PLC.
it's not the mainstream brand.
Yeah, it's not first time. Then I just Google and see, like you said, what company they.
Overall.
No, I mean, what company providing
Oh,
techniques
SCADA.
they are the only
Yeah, in Malaysia. Yeah.
Malaysia lah.
The only-
Okay, but I think T-boxes look like more to RTU model,
Yeah.
right?
Yeah.
RTU models.
Yeah.
Okay, because there's a difference between Schneider PLCs and other PLCs. Like Schneider backoff is like running on they call code sys Windows. Like there's their operating system is like a window. So that's why they're using the IEC standard. So means you can use ladder programming, function block diagram, structure tags, and even I think can use the SFC programming also, sequential function chart. Okay, yeah. So it will be similar to some other models lah. Okay, like Siemens all they have their own OS system. So their way of programming is different. Siemens, Omron, Mitsubishi, LMW, most of the brand. Okay, right. So all brand are same lah. Same. The thing is, okay, you give an input, you program, your output will react according to your program. That's very simple. Okay, very straightforward. Okay, so it's depend on how big and how small is the program. What are the components? What are the devices you want to control? Okay, so yours is a water treatment, right?
Yeah.
Then you should know Swiss water.
Switch. Service water.
Swiss SUEZ. Swiss water is a company.
Oh, company.
Yes. Never. They also water treatment plant.
Or
In Singapore.
Singapore.
So last time I have their participant last time 2 or 3 times when they come here. Few times they come here for trainings. Because first time they come, one engineer and one manager come. Then the second time he sent another engineer for training. I know last time they have they do some servicing in Sabah also lah. They give this apply this water treatment there. So theirs is like one of the part on the water treatment plant system lah. So they just like a plug-in, just plug and play system. So they have their own control. So the client side they have their own control. So they just go and fix the system. Just send some data to the client side. So they use. So last time because their system using Omron, but the client system using LMW. So they come here to learn LMW actually because they know Omron, but they don't know how the LMW works because they need to send data to the LMW, right? Yeah. Need to integrate. Nowadays that's the main thing nowadays because nowadays most of the people now they know the basics of PLC already. Just they know how to integrate everything. Yeah. And some more this one they famous for Modbus.
Yeah.
Yeah, because actually Schneider Schneider is actually different, right? And Modicon is the one of the, actually that's first PLC, Modicon. Then Schneider buy over Modicon.
Oh yeah, I see Schneider is focused more on electric.
Yes, electrical parts, electrical things. Then when they come for automation, they buy over. That's why Schneider, they call Schneider Modicon. Sometimes the part number also. That's why I think whenever we have email, we have some confusion on the part numbers also.
Oh yeah.
So some they call like this one lah. Okay, because in the hardware it shows TM221.
Yeah.
But some they call M221 only. That's sometimes always. Actually, another thing is Schneider very rare I do training. I think this year I didn't do any training for Schneider.
Oh.
Last year I do one training.
So this is the first time.
This year first time.
Oh.
And control expert also not very much into training. Normally I do training for this one. The EcoStruxure basic.
Oh.
Basic. And last time I did one for machine expert. That one is using the TM241.
Oh.
Yeah, 241 and another one.
Because for this control expert need to have license, right?
Yeah.
Yeah. For basic you don't need.
This one is no need license.
Yeah.
Machine expert need license and control expert need license. And last time what I did is the machine expert I don't have the license. But they have 7 days trial.
Yeah, 7 days trial.
So what I did is before the training I just installed 1 day before because there's a 5 days training. He come from all the way from he's a Singaporean but he working in Saudi lah. So he come for this training. He also bring his PLC because TM241 I don't have. Then I say if you already confirm then I can buy because TM cheaper lah compared to this lah.
Yeah.
Then he say never mind IF. He say EF the model, so he bring his 100. Because very rare this one. If no, we can invest because you see like Omron,
Yeah.
you got so how many Omron, Mitsubishi, Siemens, all. If you ask me Siemens, I have complete set. Electrically complete set I have. All different from the old model until new model. Their VFD, their PLC, their HMI, all I have.
Oh, you also provide training for VFD, like for Schneider VFD, Motiva.
Can do training, but the thing is I need the hardware. Because last time I did one install. Normally I do training for VFD. I try to integrate with PLC.
Yeah.
Not just the VFD training.
Yeah.
The VFD is very straightforward.
Yeah, just control the motor.
Control the motor, but I don't go deeper into VFD. Means I just do the basic parameter settings, just to rotate only. Normal rotation, not like controlling top controller position. No, I don't go there. But that one, it will take time. Then there's a lot of calculation involved, right? So I just do normal, just on off and control the speed trains. Normally I will try to integrate with PLC. So PLC control. So I don't do like strict normal control, direct control. So PLC I use communication frequency. So I either use analog or the communications. Okay. Then actually, but you take 3 days training. If you take 5 days training, I have one drive that is Modbus. Can use Modbus. And Modbus is like they use the RJ45. So you use these ports actually. This port also can use. We'll try and see. The day we have time and see. So you using what drives? ATV?
Altiva 630. The one is for bigger motor.
Yeah.
The smaller one is Altiva. I forgot the because Altiva 630. The one is the bigger one. Another one is the small one. The
320.
320.
But that's a lot of models.
Yeah, that's one.
Because last time I set up one for one company. So their whole VFD, whatever is, the last time I'm here, I think, April or March then. Around that time there's a bungee here, JB through.
You are now currently in Sabah?
I
Yeah.
in
Yeah.
Sabah and Perak also some place.
Yeah.
And here was very thorough. So what happened? At company they have a system for filling the oil filling machine. Very simple machine. The problem is, let's say this is the machine. Here is the PLC panel.
Oh.
So when the front come spoil everything. Luckily during the time they power off the system. So what happened? After that they let it dry because this is a very small company. I think this big also the company. Like a small industry. So they call me, then I go there. Then problem is what happened is they're using Mitsubishi PLC because of the flood, right? So these guys are IT guys. So they know a bit about the what they say electronic components lah. So because they open up their but the system, everything, they clean up everything, right? So the same thing he do. But what happened is in Omron PLC, Mitsubishi PLC, there's normally we have a battery inside, like a computer with the BIOS battery, right?
Yeah.
So what happened? That guy removed that. So the program inside lost.
This one is for backup.
Backup the
right?
program. Yeah. So it's lost. So then I go and redo the program, and he have very simple. He have two inverter. One is controlling the conveyor, one is controlling the pump. So one of the inverter is spoiled. So he asked me what inverter to buy. Say you can buy any inverter, make sure can control based on your how big is your motor lah, how many kilowatt. Then you buy the Schneider one. But I just use the normal control. The speed, everything set in the drive. The PLC only can send on-off signal. Very basic control. The one I use the one Schneider ATV, something very small, it's big only.
Yeah. We also use
1.5 kilowatt.
Yeah.
ATV 31 or something like that.
G12 if I'm mistaken.
Yeah.
I think it's G12.
ATV 12, sorry.
Oh.
It's very small. ATV 12. Altiwa 12. But there also got so many controls actually. But Rogi lah, they just controlling just on off only. Controlling the plugs. Okay. Alright. Okay, so that's about Schneider lah. Okay, Schneider, because last time Kelly Mechanic also is actually under Schneider.
Sorry?
Kelly Mechanic.
Oh yeah.
So like just now you said right in the last one, guy bring the one it's a Kelly Mechanic model. TS something model. So the one is using the Unity Pro. Unity Pro is the one later on they upgrade to Control Expert. But of course every time they upgrade in the PLC there will be a new firmware. So all that are same thing like. But Arduino there's not considered as a PLC lah.
Yeah, it's not industrial.
Yeah, it's industrial. But they also have one model, industrial model. One model, but I don't know what is the model, but it's industrial model. Is this normal because Arduino normally like a microcontroller, right?
No.
Yes, they have one of the controller is an industrial standard. I think you can see in their website. It looks like this color, white color. It's like a PLC industrial standard. Okay, next. Alright. So this is how the PLC works, right? So digital input, analog input, connect, then the PLC will process, then it will give to the output, then the output will be your digital output and analog output, right? Then this one later on you can copy this file, these slides. Okay. But that manual actually I don't have the Control Expert manual. That one is for this manual. Yes. But later on I give you the this for this manual. Okay. Then of course any PLC use the most important thing their software and also the communication. Most important thing. Okay. Okay. Computer numbering system. Actually, this one all we learned before, lah, right?
Yeah.
Just to refresh on me. Okay, so computer numbering system, because PLC also using the same numbering system. Decimal, hexadecimal, octal and binary. Okay, next. So decimal, the number we use every day. Okay, so like very simple lah. The base is called base 10 lah, right? Then it's a 0 to 9, then continue. Okay, 10 to 19, 20 to 29, until infinity. So normally the numbers we see in the HMI, in the program, normally they will use decimal. Okay. Then we have hexadecimal also. Hexadecimal are normally mostly used in PLC, computers and some digital equipments. Okay. So hexa is 16 numbers. Normally very common in drives. In drives. Because let's say for example, you want to control a drive using a Modbus. Okay. So of course lah, you need to go to the drive manual. You need to see what is the Modbus address, right? Modbus value, everything. So when you see values, everything, they mostly use hexadecimals. You very rarely see decimal in their manuals normally. Because hexadecimal is common for, like PLC lah. PLC very common hexadecimals. But normally when we want to control another system, then only we use hexa. Even within the PLC, we can use decimal, no problem. Because PLC can use decimal, hexa, octal level. Okay.
Okay, just double check the name and I see and then send it over here for the link. Alright, thank you.
Okay, next. Go to this one. Next, okay, binary. So binary, we know that 0 or 1. Okay. So actually, our computer, our system all running on 0 or 1, right? Decimal, hexadecimal is actually for us to understand, for us to give value. PLC or computer at the background, it run on binary only. Okay. And octal. Octal mostly used in early PLCs. Okay. Actually, this one they don't call PLC, they call PAC.
PAC.
Yeah. Programmable Automation Controller.
Oh.
Yes. If you go to their manual or their, you go to, actually normally the manual they call PAC 340, PAC 580.
Oh, just for this model lah.
For this type of models. This type they call PLC. Because this one is like a bigger system. So it's not only a logic controller. It's an automation controller. It means this can do more than logics. So you can create logics, you can create the visualization. So this one they call PAC. Normally this one and Schneider actually. Actually this one and Schneider is back off. This one in back off mode. The concept is similar. It's more to PAC. Even the back off also they call PAC. They don't call PLC. It's not a programmable logic controller. No. They call programmable automation controller. Yes. Because why they call that? Because the PLC, like Siemens, they have their own software and we can download. Normal logic ladder programming, structure types of programming, function block programming, normal programming. Then if you want to create a screen or something, need a HMI. For this and back off, within the software we can create like a visualization. Yes. So you don't need HMI for that. If you want to, means there's no HMI to do. You can download. For HMI, there's a different software to download using, right? That's why they call it PLC.
It has built-in HMI.
Yes, building like a building lah. HMI, VFD, everything is in the same software. Right? It's like a controlling the whole system. Okay. That's why the laptop must be not powerful, but must use like Windows professional version. Professional or ultimate. If using home version, sometimes some of the functioning will work. Because this one also the same. I install, but whenever you open the software, it will show one error. But after you uncheck the error, it can work. Okay. Alright. Next. So Octal is actually basically normally used for Siemens PLC. Because it's a 0 to 7. Yes. So they have 8 numbers. Then 10 to 17, 20 to 27. Okay. So Siemens, almost not other than Omron, some of the Japanese models they use Octal. Mitsubishi, Kions, Delta. What else? Yokogawa. Yes. Same. They have some of the systems are using Octal. I mean, mainly they are addressing the input output are normally they use Octal. Alright, next. Okay. So this is the difference lah. Okay. What decimal, hexadecimal, octal and binary. Okay. Actually you can use a computer calculator. Next part. So if you want to, let's say for example, you want to control a drive, okay, then you open the drive, then you see it shows in hexadecimal, but the program you want to do, let's say in decimal, right? So just can use our computer calculator. So just open a programmer calculator from hexa, just key in hexa, it will show in decimal also. Actually, sometimes some of the participants, have you used before this? No. Actually, normally what they do, they use handphone, Google, right? Convert, everything. Actually, our computer itself, they already have one from last time lah. One from Windows XP. Before that also, they already have this. Because you see why? Because computer programming, they need this. Normally, computer programming, they will use these two common. Because why? Why they use hexa? Actually, I also wonder why they use hexa. Then I go and just see that some manuals, everything like that. Then only I know. Because you see, hexa using less number of digits. So let's say in the normal number, like decimal is 100. In hexa is 64. Means just 2 digits only. But here go to 3 digits, 4 digits. So that's the difference. Okay, that's why they're using hexadecimal. Alright, next. Okay, so this one is your model lah. Okay, for your model, this one I take from the manual. Okay, so this one is yours is a 342. Right, 2. 342020. This one. Alright, okay. So this is the one. 2020. So this back input output you can go up to 1000 IO lah. Okay, 1000 digital input output. Okay, 1024 actually. Okay, 1024. Then analog input output modules can go up to 256. 256 and expert channel means like you want to control PTO means it's a pulse. Okay, pulse. So means like encoder, servo motor, all that is running on pulses. So you can go up to 36. You mean 36 address for that lah. Okay, counting means it's like a high speed counter that they call input. PTO is the output, so it's for controlling servo, controlling valve, because some valve can control using pulse. Okay, I mean not valve, actually it's a flow meter. Then network TCP/IP can got 3 network, 3 TCP serial port lah. One serial port, one Ethernet port. Okay. CAN open also is another type of similar to Modbus. Okay, CAN open. Modbus is like a communication protocol, right? Ethernet is the because normally this is what normally they confuse. What is Ethernet? What is Modbus? Okay. So Modbus is like a protocol, communication protocol. They have their own communication protocol. Modbus, I mean Ethernet is their way of sharing data, because you can use Ethernet or serial. RS232, RS485, right? So it's like it's actually that one also is a communication protocol lah, consider, but they more to their how they share the data, how fast. Basically this one lah, how fast and how many connections they can do. Ethernet and serials lah. So Modbus, CAN bus, or for Siemens they call Profinet. Yes. For Omron they call fins. Fidelity Internet something. Network, Fidelity Internet Network System something. Then Mitsubishi they use CC Link. Okay, so many. Okay, so many way of protocol lah. They have their own way of doing the settings lah. Mainly that is the difference between all these different different communication type. Mainly their settings are main difference. Okay, the main idea is share the data. That's all. Okay, so memory size is 4 MB memory. Okay, alright. Next. Okay, so for internal memory we are using this one, right? Okay. So internal memory bit lah, memory bit I use M and the address. What address? So can go up to 32,000. Okay. Then for input output they use for input they use I and the address and Q. The address. Okay, depend on the number will be the right number. The stop number. Input I, then the stop number, then the head bit, they call head bit, then the byte and the bit numbers. Later we see when we do programming. We have 3 numbers, okay? Because using the slot, right? So the first number will be the slot number. Okay? Then the system bit. Internal bit is like a memory for us to do programming. Okay, they call some PLC they call internal relay or memory bits. Okay, because of course the PLC cannot only use input output to do programming. Right? That is not purpose of the PLC actually. PLC they created from relay system. Actually last time they used relays. I have seen before, because very hard to see nowadays only relay systems. Have you seen before? Only relays without PLC. No, very hard to see. Because that one all I think in early 2000, early 90s, that time only PLC boom up, right? I mean when actually PLC started in, if you ask me, 1960s lah, late 50s or 60s. That time, because when the computers start to grow, right, then at the same time the PLC started to grow. From a controller that can program. Earlier they have a controller, but it's like a relay system. Internally it's like a built-in relay, so you cannot do like a programming. It's based on in this one you written if you connect 1 and 2, like a relay with a logic. 1 and 2 is on, output 1 and 1 is on. 1 and 3 on is output 1 and 2 on, something like that. Okay, then after that they come up with a programmable controller. That is, connect input output, you can program. So you don't need a relay. So I have seen a relay system, because last time we do projects on and off. Last time when my boss is here, before 2021 and so my boss do the training. So I'm more involved in projects, doing the control panel, doing the wiring for the panels. So last time we did a project for a company, a small panel, 8 panels, 1 meter height, 8 panels. They have old panels using all relay system. It's like a door control. So they in the room they have like 2 or 3 doors. Let's say this door is open. Let's say here I have another door. This door can open. Make sure that door is closed and then only this door. So they use a relay only because it's a very simple system. Just an interlock, right? So I convert that into PLC. So I've seen before. So nowadays very hard. So the memory is called like the internal relay. So because we take out the relays, put a PLC ready. So when we do programming, we need some internal memory to keep our data right. Because you cannot do that straight away start output on. Some can lah, some simple system can lah. Because sometimes we need like memory keep our data first, like an interlock. So let's say these are the sequence. First sequence is done, first step is done, first process is done. I create memory. Then second process. So for that all we use memory. That is the function of the memory lah. System bit means this one is a user defined. We define our own. So there's a 32,000. It means we define our say. System means system give you the bit. Means like the status of the PLC, whether it's a run or whether it's a fault or if there's an issue, there's a error on the hardware, like time second, okay, time second or all that will be system word actually. Bit, because bit means on and off, 1 or 0. The time will be under the word. Okay. Then internal word. This one same lah. This one is same memory. But this is a bit. This is a word. Okay. Then a constant word. Constant word means we can key in values for constant numbers. Normally numbers values. Then system words. Okay. So this one is the one we use because its default size is the 512. These are the numbers lah. Want to increase maximum can go up to this. Okay. Alright, next. So next in PLC, the data type is very important. Okay, because we have boolean. Okay, boolean, short integers, double integers, real. Actually, this is not the whole data type. This is the basic data type, the main data types. Other than this, just follow this only, these numbers only. Like they have string, characters, everything. So they have some values, alphabets, everything. Okay. So boolean means 1 bit, on or off. Okay. Short integer means 1 byte, which is 8 bit. So in the short integer itself, they have a signed and also unsigned. Very simple lah. 1 byte. If the 1 byte, if all 1 1 1 1 1. If an 8 bit, right, you will get 255. Alright? So that is called unsigned. If you make it like positive, negative, you will get this number. Very straightforward. Okay? Then integer is a 16 bit. If let's say all the 16 bit is 1 1 1 1 1, then you will get 65535. If you want to make it into like a positive negative system, they call sign integer. Then negative 32,768 to positive 32,767. Just make it positive negative. Okay. Then double integer, which is 32 bit. So why they have different? Common boolean, integer, double integer, real. These are not very common. Some PLC only use this. Okay. Why? Because of course boolean we know that is on or off. But why they have like integer, double integer, 2 types, right? One is 16 bit, one is 32 bit. If the value is smaller, we can use this. The value is bigger, more than this number, then we have to use this. because this one can go up to 4 billion numbers. The value we can go up to 4 billion. If negative positive means negative 2 billion to positive 2 billion. Okay. Then real, or they call floating. This one is very big, 3.4 exponential. It means the number is very big. But the main thing is, real means can keep decimal point numbers. So if there's a value, there's a calculation you want to involve in the point numbers, yes, then I have to use real. Just a normal number, normal integers, then we use this integer or double integers. Okay?
Later in programming, can we use all this?
Oh yeah, of course. Sure we will use the bit, right? Then later on we will use integer, double integer, real. Carry. Mostly second day or third day onward, more on this stuff. Okay? Good. Next, I think I did here. Yes. Any question? So far, okay, yeah? This one very basic. My slide is up to this only. Because after this, more to hands-on. Because we need to go inside the PLC, everything. How we set up the PLC. This is the power supply.
Yeah.
So means your company supply water treatment.
Actually, we operate the plant.
You operate the plant.
Yeah.
Oh, you are not supplying. I mean the system.
No, we
Oh.
operate the plant. We operate the plant auto operators.
Oh. And can do the PLC, right? This one here is the memory, is it?
I'm not sure about this.
There's a memory card.
Oh.
Memory space is memory card space.
So in the diagram is only the one that we have right now. We have stored. We don't have the 6 slot. That's why I have to do this.
Yeah. Because there are so many timelines.
Yeah.
Then on the analog input. Schneider, if not mistaken, the 340 and the 580 is the high-end.
Yeah.
Other than that is 241, 251, all that is second one, this one is a low. Actually they have another one also. Good one.
Or the Zilio.
Yes.
Yeah. Okay. The 580 is the highest.
Yes. according to this one, right? Okay. This one error because it's not in the CPU. Because in CPU maybe the position everything. Inside. Okay. Using that. Okay. Right here I bring the USB. Okay, connect this USB. Do you have the software?
In my here,
Meaning for your laptop or your company
yes,
laptop?
I have. But we using this or
Yes, you do. Okay. If you want to use your laptop, it's okay. It's up to you. Ah.
I will use here.
Yeah, you can use this. Later on, you can copy all the files lah. We do. You have any company projects? Company the machine program?
Program, yeah, I have.
Okay, good. Then it will be helpful.
Yeah. It's like I want to
Ask and
Yeah.
also lah.
yeah. Okay, you have to because currently the program is using the function block, but we have an issue that the PLC is polling 5 bit VSD
Okay.
simultaneously.
Okay.
So the issue is the data is corrupted, and I suspect because of the cable or degraded or idle port, because the area is very hot, high temperature because of the
Okay.
VSD.
Okay.
So, but this issue is just new issue.
A new issue lah.
Previously,
Don't have this issue.
Yeah.
Okay, so where you get the data corrupted, that message? In the PLC side or?
I look into the PLC.
Okay.
The data is not clearly with the VSD display. Since VSD got its VSD display, right?
Okay, yes.
So the value is
Not the same.
Yeah, not the same with
The PLC.
Yeah.
Okay.
So, but I tried polling just 1 or 2 VSD. So the data is
It's
correct.
same.
Yeah, the same.
Okay.
But when I try to poll all 5 together simultaneously,
Cannot.
yeah,
Oh.
I don't know what's the issue. Maybe because of the cable.
Cable, because when you want to control the five VSDs, right?
Yeah.
There must be cable, and your programming also must be correct. Because you need to tell, okay, this data need to go to VFD1, this data VSD2, all that. So when we do this configuration, addressing, all must be correct. Okay, never mind.
Later I will get to see the program now.
Okay. That's better because so I can get some idea.
Yeah.
So what type of programming they do, right? So I can customize on that.
It's actually done by our contractor. So
Who is that?
SNB solution.
SNB.
SNB solutions. Yeah. Sabah.
Sabah Life.
Sabah British.
Okay, first we try to upload lah. Okay, so you know how to upload?
But we don't have need to do some program, right?
No, not necessary. First thing, okay. First thing we go to device manager. Go to port. Go to go down. I think it's connected this one. Yeah. Think so. Go down. You go to use USB. 1, 2, 3, 4, 5, 6. Right. Okay. You remove the USB from your laptop. Still 6, right? 6. Because I want to know what is the okay, I mean, connected. Okay then. Okay, I mean. Okay, this is the error I get. Okay, I mean. Okay. Now go to connect. Go to PLC. Go to connect. PLC project content false bits. Okay, okay. Different. Okay, go to PLC again. Okay, transfer project from PLC. Okay, transfer project from PLC. So not necessary to create a new project. Because creating a new project means you're creating a new file. So that way also can upload, no problem. Yes. So this is the program that is inside your PLC, right? Okay, go to configuration. Yes. So this one that we have 32020 and they have 64. I think it's a 64 input, right?
Yeah, digital.
Digital input, then DRK is what? You bring the mouse here. Just bring oh, relay. Okay, relay. Yeah. Relay output lah. So 1, 2, 3, 4 relay output, then analog input, right?
Yeah, yes.
Then it's analog output. Okay. Alright. You open this. Yeah. Then this is the back plane, right? Yeah. Click here, then you can see all this part. Okay. Then go to FB style. They use derived timer lah. Okay. Never mind. Go down. Okay, go to elementary variables. Double click. Okay, can you see? These are the what they call variables. Okay, variables means all the input outputs. Okay, not only the input outputs, all the address lah. Normally we call address lah. Okay, all the addresses that I want to use here. Okay, but whatever they use some as the variables. Okay, so all these are variables, all real, right? Real inside, and this is the internal. Can you see MW220, right? So MW means is the, like we said just now, you see memory input. Yes. Okay. Then okay, go down option menu, right?
Yeah.
Then you can see the data types. This one we can choose. Okay, we can choose all these data types. Okay, so MW. What else address they use? All MW. Okay, this one is the DIDO. Any memory bits? Memory bits, I mean boolean lah, maksudnya boolean. This one, memory bits. This one is from the HMI lah. From the HMI TGA. TGA should be the model, right?
Actually TG4.
TG4.
Yeah, TG4
Is the model?
no, it's
Your-
location.
Your term lah.
Okay, yeah.
Location.
Yeah.
Okay. Answer IQM. These three only.
IQM.
Yes. These two, three only. Should have analog. This one is a analog. If IW is an input. Just I, then the numbers is a boolean. Boolean. They call it e-bool. What e-bool is the term they use because it's an equipment boolean. If you see the memory, you go look for memory I. This one, see? Boolean, right? E-bool. Okay. Then this one they call unsigned integer. Yes. I think this one is one of the analog output. QW. Okay. Okay.
This one, what is?
HMI variable they're using for HMI this one.
Oh,
So I think in here itself we can use HMI. I think this program is big lah, but so many IO, right?
yeah.
Yeah.
This one is for browsing.
Can you see array? Right.
Yeah.
Array means okay. Array means you make it bigger. One of integer means array means they like a set. A set of boolean or set of integer, set of double integer. So they put like one of one, right? It means only one lah. Okay, like these two means when you click here, they will have two. Two array, two set of integers there. Okay. Good. Okay, you go up, go to your any of the input. Yes, this right. Okay, what is this meaning?
Output.
Okay, the first zero is the rack. Okay, So this one like a rack 0. Then let's say for example they have a bigger system, they need to have another rack, right? So that will be, that IO will be rack 1. Okay. Second one is the slot. Uh, 0, 1, 2, 3 and so on. Okay. Then the last one is the number lah. Okay, how many inputs? Okay, so you go up. Okay, you see, because your input, if you see, your input will be I 0, 1 or 2 only. This 2 only. 1 or 2, this number only. Because this one is 3, right? Because slot number 3. So your analogs will be, your analog input will be 7, analog output will be 8, 9, 10, 11. You go and see analog output, you look for analog analogs, QW. You scroll up, just now you see QW. You see QW 10. QW 0 because this is rack 0, back plane is 0. Then the 10 is the 10 slot. 3 means number 3. Yes. Channel number 3. So always start with 0. Channel 0, 1, 2, 3. So if it is look like, because I see 4, it means I think so it's a 4 channels. I think so. You go to, later we see. Okay. Go up, key in from the HMI, MW up. You see your input is only 1 from slot 0, sorry, rack 0, slot 1, number 0, power supply. Yes. So that is the addressing format. So output all 313. Input you will see. Go to I21 because you see your input, first input is a 64 inputs, right? So can go up to 0, 1, 0.1.0 until 0.10, sorry, 0.1.63. So their format, the numbering format, they use decimal only. Normal decimal format. There is no special. Like this, like a Siemens, they use octal. Means okay, I 0.0 until 0.7. That's all. Until later on 1.0, 1.7. They using slot number. Slot number normally they use like this lah. This is slot number lah. They normally use in Schneider. Okay, the 340 and 580. Then LMLE, back off. Other than that, as I know lah, GE for this one. It's also same. It's they use a rack, but they don't use a slot. They don't have 3 numbers. They have the slot and the number. Okay, good. So that is about the addressing lah. Okay, go down. Okay, that is the elementary variable, derived variables. Okay, this is their like for scaling like for PID everything like they use this. Okay. Slowly input, output. Okay. Then the derived yes, device thing. Okay. IO derived variable and the elementary FB instance. So many FB the function block, right? All these are what their own function blocks. In Schneider function blocks, PID, scaling, PWM, timer. Of course, they use a lot of timers. Then derived FB instance. This is, I think, their own function block that is here. These two function blocks. All these we will learn how to create all this. Okay. Alright. Then the program is here. Communication, put the communication. See what I do. They do networks. Okay. Then yeah. Put. Yeah, I need the IP address. Yes, correct. Okay, they open this. So you take note this IP address. And 2024. Okay, because now the upload, right, we actually use Ethernet. That's why I didn't ask the IP address. If I just connect just now, if I remove the USB and I just click connect, it cannot connect. It will ask for the IP address, and my laptop IP address is not the same. Yeah, because here itself it shows USB. Okay. So this one bring it down. And 2024. We leave it this IP address, or we want to change the IP address also can, no problem. But this PLC, are you using this PLC or this is a spec? So like we save this one, we save this file lah. So later on we do our own file, I think. Then later on this one we can transfer back to here. Okay. Alright. Then your program is here. This one is I think they use their own name lah. Okay, mapping, IO address, calculation. So they use a ladder, structure tags, and function block tags. All the three lah. So we also learn all these three. Can learn. Okay. Properties. Ladder. Okay. So like okay, when you see like this, right? There's a no address, correct? You click here. Okay. So it's a, there's a name for that. That's why it's straight away show the name. Because a variable name lah for this address. For this one, you click here. Why they already show? It's showing the number is because showing the address lah. Because there's no variable name for this address. Means they didn't add this a name for this address. They just use the memory. Okay. Alright. Okay, this normally open, normally close lah. Okay, all these functions are here. Right. Okay. Then the counter timer all is here. Okay, hold on. All same only lah. Because why is same? Because they use a IEC standard. Okay. Yeah, check what is the IEC standard. Okay. The number is IEC. IEC 61131-3. That is the IEC standard. So means in this standard, any PLC following this standard, the programming way is the same thing. Because this timer, right, exactly same in this Siemens, the new Omron. The old Omron not like that. Old Omron is a different way. They call mnemonic way. Then this one is a new Omron is using that. New Mitsubishi is using that. Then Schneider, all that. So because now all these PLCs, everything, they have two types. Because last time they have their own way of, blocks. This one called blocks. So own way of blocks last time. So nowadays what happened? All these are following their standard. The standard is they call IEC standard. IEC 611-31-3. for programming language lah, for PLC especially. This is for PLC.
So it's been standardized.
Standardized. So, but this one no, this one different.
This one.
Yes, this one different. I mean the way of using the timing and everything, a bit, little bit different. Okay, right. There's a delay start. Okay, go down. Okay, comparison. Okay, click here. Bring the what comparison? So this is no, the expression is there. This is the something equal to 0. So this is your one of the variable. Value lah. Keep value. If it is equal to 0, okay, that is compact. Because okay, go down. Because since the name is very big, that's why it cannot show the expression. Okay, operate means like moving lah, moving data, everything. Okay, go down. Timer, because I want to see what are the functions they use. Because of course normally coil will use, timer will use, set reset, right? Just now I see set. SNR we will use, okay. Mostly that normally. Okay, then mapping the IO address. So what they do for mapping, they use the structure text lah. Means actually this one means this is the input, this is the output. This is the normally open, this is the coil. They just do the mapping. Means this one, when this one on, when this one true, this one true. When this one true, this one true. Then this one they say send somewhere else the file. Okay. Alright. Okay, mapping. Okay, this one I think is the output mapping here. This is the output mapping one, right? IW7 is a analog, right? Oh, so this is analog mapping. Okay. So this one is a chlorine drum weight. It's an input. Input. This is the output. Yes. Can you see the name they use? PLC.
Yeah.
PLC is actually they refer to your PLC.
Actually, this PLC is chemical.
Oh, chemical.
Yeah.
Not
PLC
your.
is one PLC, chlorine.
Oh, not your. So it's not referred to your. I mean your PLC name lah. Oh.
Yeah, because
They put
PLC
PLC
is
here. Okay.
yeah. PLC is our chemical to check the durability.
Oh. Okay. Okay, never mind. You don't do any changes, you save first. Save. Yeah. Save to a folder. Go to desktop, you create a new folder, you give your name. Yes. Okay, then you can put like a upload M340 upload. Okay, save. So when you want to download, it's the same thing. Go to PLC. Wait, there is it. Okay, go to PLC. Okay, then transfer to PLC. That's all. Very straightforward. If you just now you don't have this, correct? Just Just now you only have this because why? We didn't create a file. Open the software, we back up. Alright, now okay, what's the okay. We take a break, go for a break, and then after the break, we come and do the new project lah. The new project, we do the hardware configurations, and then one by one. Okay. But I don't think so we can use I mean physical input, physical output lah, because you don't have, right?
Yeah.
But normally we use the memory lah, do the programming. Okay, so anything you want to ask, you can ask me, no problem. Okay, what is this function?
Also, can you teach me how to? I mean, we can simulate here, right?
Yes.
This.
Can. There's a simulation, very straightforward simulation. Okay, so you want a coffee or tea? You can make a coffee or tea there. Okay, back. We have a pantry. You are smoking, you can smoke down lah. Okay. Where you stay? Okay. Where you stay?
Paradigm.
Oh, in Paradigm. Then you take a Grab lah.
Yeah.
So yesterday you reached JB.
Yeah, yesterday around 3 p.m.
Okay. Senai lah.
Yeah, from about Sunday.
Then when you going back?
Saturday.
Saturday morning.
Since we are our training
Until Friday.
until 5 p.m.
Yes. So Saturday
morning.
lah. Yes, nice.
Can I take this?
Yeah, it's for you. For the participants. Because our break also need some breaks.
Yeah.
No, for me no problem. For me teaching only. So I can continuously teach, no problem. But for the participant, sometimes I continuously teach, they cannot catch up.
Need to digest.
To digest because I give a lot of information.
Yeah.
Hey, you want a coffee at the back?
Okay, sure.
So your name is correct, right? Your name and IC.
Yeah, correct.
Okay, good.
Okay.
So for your later lunchtime, lunchtime is 1 hour. So here below there's a 2 Indian restaurant.
Oh, yeah.
Okay. But at the back there there's a mama shop also. It's a
Oh,
walking distance now.
listen,
Yeah,
yeah.
you can go there also. Perfect.
So we lunch at
12:30.
So
12:30 to 1:30, yeah. No problem, but timing can adjust, no problem. Because one pax only, right?
yeah.
Then on Friday, how? The Friday prayers?
I think since I'm traveling, so
Yeah.
I'm not going out. So
You can pray in the hotel also, right? Because if you want to go, there's a masjid here also. But it's not a walking distance. You need to take Grab, but very near. It's around less than 3 kilometers only. But it's not walking distance. Here near, because in front here is a taman. I think morning just now, maybe I think you will be on the way that way only. I think so. Morning. You just now you take a Grab, then you take like a flyover, right?
yeah, forever then you turn.
You turn right, then you straight come here, right? On the way only, on the left hand side there's a masjid, but it's not walking distance. Right. Now, we do go to file, new. You close this one, then we can create new. No need to close this. Okay. And cancel.
Disconnect.
What is disconnect? You can go to file here, close. Yes. Okay, that one go. Pause. Okay. To file new. Okay, so your model is 3420 Modbus and Ethernet. Okay. Then your backplane is a Ethernet backplane, right? Okay. So backplane here also got backplane, but this is not an Ethernet backplane. VME or VMX? The back is it?
BMX.
Okay. Okay.
Okay.
Yeah, because this one can go on up to this only. M550 and 340. Yes. Okay. No need password. Cancel. Before that, okay. What is the IP address now?
10/20/24.
Oh. So your CPU is 10/20/24. So the PLC, sorry, the PC we set 10/20/20/10.
10.
The first 3 number must be same, last number must be different, right? So we set your PLC first. I mean your laptop. So right click open that. Change the data option. Internet is not connected.
Yeah.
Check your laptop. Set. First you bring to this. Bring down it. Okay. Check on the
Oh.
is it loose?
Yeah.
Okay. Okay, now okay. Normal. Always my the clip always go. Okay, now go to TCP/IP 4. Then subnet mask I think 255, 255, 250. Okay, okay. Okay. And close. Alright, and close. Okay. Now go to PLC bus. Okay. Now we add the device. So first slot is 0 in your PLC, then this one is the CPS 2000. Okay, is it same CPS 2000 or some other?
This 3000, 2020.
320,
3020.
3020, then I need to change.
Oh,
You can use this supply here. 3020. Yeah.
3020.
Yes. Just drag and put it here. Yes. You need to delete this one. Right click, delete. Delete module. Okay. Now you add this. Okay. Just a drag drop. Very straightforward. Next, after that is the communication, right?
Communication.
Communication. Okay, go to under communication. Okay, what is the model?
Okay, this one. No, 0200.
Okay, yes, you add that. Okay, then your second one is the analog output. Okay, put analog out. It's what? AMO 04
0410.
0410. Okay, there's a 4 analog output. Okay, save. You can name it as day 1, lesson 1. So we will be doing multiple files, multiple projects. Huh? Because whatever you do, okay, once done the configuration, okay, you save. Then once they do the IO list, okay, you save. Whatever you do, save, because I scared the software suddenly off or the laptop suddenly off and the program is wasted. Okay. Then this one can close. Close. Okay, go to variables. I want the elementary variables. Okay. Now you key in here. So we can key in here, but since you don't have the input output, right? First we use the memory and do the projects. Okay. Then later on we create another project that with the input output we use simulation. Yes. Okay. Now just create a simple one. Start. Okay. Enter. Okay. So it's a boolean. So value no need, comment no need, address. The comment you make it smaller. Okay. The address is address I want to use memory. So memory bit is percentage M0. Enter. Alright. Start, stop, then one output. M1. Then output is let's say motor. M2 or M10 and M10. Yes. Okay, finish. So this is where we do the all our IO. So they call variables. Okay, Schneider they call variables. Okay. Okay, finish. Then we go down, go to our task. Okay, under the task, the master, open. Okay, logic. Yes. You right click. New programming unit. Okay. So main lah. Main. Okay, go to localization. Okay, function modules. Function modules you click here. So the task is under this. Okay, condition. Okay, variable name only. Okay. Command only lah. Protection. Okay, no protection because you can put protection is read only. Means you cannot write a program, so you need to put a password as well. Okay. Click OK. Alright. And the name. Okay. So it's like you create another folder then. Okay. You go to the master. Right click. No. You click on the logic here, right click, okay. New section. New section is the new, we call it, how to call it, like a block lah, like a programming block, new blocks, okay. So this is where we do the programming one, right? Okay, let's say we want to do a simple program, start stop motor with a timer, everything, right? Okay, let's say you put a motor control. Control, can space. And the language, you there. You see, you have all the languages in programming, but this one is first time you see. NL984. Oh, what is the language? Oh, it's only for control expert. First time I see. Tech or similar to ladder logic lah. Instruction set. Okay, it looks like mix of ladder and function block. I never heard before this one. Because others all I know, structure text, instruction list, function block diagram, sequential function chart, ladder. So we use ladder first. So we will learn ladder, structure text and function blocks. It's three. Because I see just now your program is all. Just now the program is your machine program, is it?
Yeah.
One of your system.
Yeah, one of.
Okay. Okay, clear. I think need no cache space. Put underscore. Okay. Alright. So this is where we create the program. Okay, so yeah, normally open, normally close, the pulse function, the output, set, reset, pulse, okay. Then this one the hard coil, coil, okay. Then this is to create the lines, okay. Then this is the operation, okay. Then the compare block. Okay, compare block is just like comparison. Operation block is like you do like a functions like match function, convert function, all that will be under the operation. Okay. Then this one is a jump label, jump return. Okay. These three is like how the programming goes. Okay, programming we call the programming execution or the programming scanning. It will from left to right and top to bottom. That's how it works. Okay. First line, okay, left to right. Second line, third line. So it will go one by one, but very fast in milliseconds. Okay. So it's like it will take like 10 milliseconds to scan your whole program, not only one block. Just now you have some multiple programming unit, routine, right? All the routine will be scanning within 10 seconds. Depend on the PLCs, okay? So jump means, so when you're scanning, right? Let's say there's one program. From here you want to jump to number 10. That is called jump.
So just
bypass some of the function, it will jump. Then it will finish the functions. If the jump is not activated, then it will normal. Yes. So all the PLC have this. Some PLC they call interlock, like Omron they call interlock clear. Okay. Like Siemens, Omron, they call this what jump. Jump like this, jump and label. Last week what I did? Oh, Panasonic. Panasonic they call master control. It's the same thing, different PLC, the different terms. Okay. Then here, this one I think is data selection. Later we see what is this, some of the functions. So it's a function blocks. Okay, this one is a library, open library. This one, this one all is for the what SFC programming. Okay. Then here, this one is just now in your program you see like the comment, right? Okay. This one is a column size. This one all like a view setting for this. And here is the counter and the timer. Because counter and the timer is like a block type. You see like a block like. Okay. Other than that, because counter timer you need that. Other than the move max function will be under operation. Compare is a compare. Other than that, it's mostly like operations. You see that one by one. Okay. Of course, we can cover everything. Okay. The most, because I write down here is the important one. Mostly commonly used. Okay. Then you take the normally open. Okay. In here. Okay. And double click here. Then Boolean expression. Okay. Click here. Then you can get this. Start. Yes. Okay. Right. Then output. Output. Yeah. Click here. And here. So it will automatically create the line. Okay, you can, I think you can key in also. Close. Key in here. Motor. Okay, clear. You bring the mouse here. No. Exactly. You bring the mouse here. Mouse. Yes.
Oh, same.
Same. Because it's already created. Because this one is like it's not like what do you call uppercase lowercase sensitive. So means let's say you create with uppercase, here you key lowercase, still the same. Okay. All PLC, yeah, all PLC like this. Okay. Then you add normally open below here. Okay, the motor, same motor. No, I mean here the address. Same motor, even I think you click here. Can I select here? Because this is the one I created here, so to show this up, you can select this or you can select from that also. The variables also. Okay. Then you add this. Then stop. Take a normally close. Put it here. This is the stop. Oh. Stop alias is equal to M1. Right. Save. Now go to build. Build, analyze project. So it will show error. Okay, what errors? Think it should be this error. This one doesn't matter. 4 errors. What error? Go up. It's incompatible. At least one channel configured. The model because at least one channel configured. Oh, the what? Your communication function. Okay. The topological type is incompatible. Why? Can you click here? Cannot click here. Cannot click now. Okay, now go to elementary variables. Type is incompatible. What type? Because that is a boolean, right? Oh, e-bool. Sorry. E-bool. Okay, yes. Correct, yes. Yes. Because if I want to use boolean, boolean only means no need address. It's like a internal variable. Okay. You analyze again. Build analyze. See? So I must use e-bool lah. E-bool means for all the any address, any name with the address, right? I must use e-bool. If you're using boolean lah. If it is internal, then you can use this boolean. Okay. Then this module. Okay. Go to this module. I think your this module. Double click. Okay, the channel is not configured just fine. You click on the channel 0. Function, no function. But we are not using. Okay, never mind. I'll just click Modbus. Okay, Modbus slave. RS.5. Okay. RTU. Okay. Now you analyze. Now you will. Process tool is not ready. Yeah, yes, because if you connect, then you have to connect to something. That's why. Which is click here. Now analyze. This module at least one channel. Ask you to configure the channel. Okay, channel 0. Okay, let's say you use the function, go to function. Character mode, yeah. RS232968. You analyze. This tool is not ready. I think we better take out the RS232 module from there. Because if there is no one, I need to configure that first. Later we'll see what configuration we do for this module. Because it's what module? BMX NOM 0200. Choose mode bus, okay, then set number. Okay, let's say you choose mode bus, okay. Then set node number, okay, master number of price, okay. Okay, we already enable the Modbus, but there's no program for the Modbus to read or something, right? So that's why what I think because the tool is not ready. No program for that, right? Maybe later we try.
Maybe
Now
now can we try like communicate with this one through serial, right? Serial transfer.
Okay, good. Later we try.
Yeah, later.
Later we can try this for it, because using for
For the later later back at Sabah facing this issue.
Okay. Okay. That's why I say even you can try for the motor also. For the drive also we can try that. For now we remove this first, then we add here, then we do the program first, everything okay, then later on we see. Okay, because I need to read the manual. Because never for you I can never use this one. I'm doing training based on my experience. Because I use this software before, just to practice, just to play around. So later on, yeah, I did. This one I have another laptop. I set up the laptop here. So we do program here, some programming for Modbus. Then we try to send receive data. Yes, just sending one data enough. 1 boolean, one value, one value enough. Okay, remove this. Where is test pen? Okay, give me. So your company not using this one?
M340 PLC is
Oh,
for simple.
But you know how to program it, no?
This one I'm no just basic lah.
Then why you didn't take for both one?
Sorry.
Why you didn't take, to learn both?
Oh, because actually our critical one is
This one,
yeah. For the critical process we use this 340.
So you have one, this is a spare unit lah.
Yeah, this is very good.
You can make this as your what? Training one.
Training, yeah.
Yes. Troubleshooting, training, you can use this. You set up one lah. You have IO? The IO?
Oh no.
Only
That's why, yeah, that's why I want to bring this.
only you have this lah.
Yeah.
Oh.
Actually, I've raised spare part. I mean, purchase for this, but still in progress.
Oh, you can get one DI, one DO, one AI lah. Because AO already have. Then this one, set up one. Then you can buy one small drive, small motor, small drives for this. So you have a complete drive, so you can do practice here, programming, everything. Then you change the configuration. Because I'm also not familiar with this one. I need to check how to do the programming on this.
This one I did.
No need to, I think just drag and drop or something. Yeah. Yes. For now it's okay lah, but once we do the addressing, right, when we do here, then we need to go and change the address also. Because why? Because for analog we will be using 2. Now the analog become slot 1 already. So in the addressing all you need to do the setting. Now you go to analyze. Okay, no error, no worry, because I don't want any error. Okay, now once done, okay, save. Next, actually this one no need like, because this one is like creating another section. From there I create another programs.
This main.
Yes, this one can delete. Yeah. Yeah, delete all. Okay. So under here, under the logic, just click one. Sorry, another. Okay. Now go to build again because we delete something. You can use analyze project or rebuild all projects. Okay.
Oh, what's the difference?
Different because analyze project means okay, click here. With analyze project is like analyze all the main files, means your configuration, your variables, your logic only. Rebuild all project means it will include all these animation table, operator scripts, documentation, everything. Okay, done. Now go to PLC. Set address because I want to use Ethernet. Okay. So PLC, okay, I'm not using system. Okay, click here. I'm using TCP. Okay, communication parameter. Okay, okay. TCP IP. Because this is a simulator. The address here. Key that. Yeah. Delete. Key the address and 2024. Okay. Test connection. Okay. Now go to connect. Simulation is there again. Of course, force me. Okay, because we want to download.
Yeah.
Okay, because that's why it shows different. Okay. Now go to PLC again. Transfer project. Yes. PLC. So, the PC project. Okay. Last build up. Okay. Okay. Transfer.
This one you have to check.
Yeah. Because you see, whenever transfer, the PLC go to stop mode. So after transfer, you want to auto run up. Transfer. Project is not defined. Reveal all and transfer. Okay. I think we should have pressed the reveal all. This time we only analyze project only, right? We didn't reveal. Okay. Okay. So now it's ready. So confirm stop. Okay. Okay. Now your PLC stop. The run is not
Blinking.
run is blinking, right? Yeah. Why? Wait for PLC ready after download. So the memory all here can change, huh? Because these two cannot change, right? Right? This one all can change. Because just now you see my manual, right? This is the minimum. Maximum you can increase, right?
Okay. Ready to stop memory protect. Okay. Before that, you go to configuration. You go to overview. You go down. Go down. Okay. Animation. Mount restart. Okay. Go back to here. Go to IO object. CPU object. Key memory. IO object. I want to see the address, the IP address. Where to see the IP address? Go to overview. Can I click on the address? Double click, can I? Even import, right? Click on the channel. Set the internet configuration. Click here. Click none. It's none. Because I want the internet address. Go to communication here. Net. Okay, double click. Right click, new. Internet. Okay. Yes. Go to internet one. Bring down here. No IP, that's why. So, okay, now what you do, you set IP address, similar to this IP address, we download it. You know, just now, what happened, I think it's already downloaded. See, it's very simple. Inside the PLC got IP address, this IP address. Now this one don't have any IP address, but we connected already. Download. After download, want to communicate using IP address cannot, because inside that there is no IP address. That's why you cannot communicate. Okay, we try. We put this address. 10, 20, 24. Then subnet mask to 255, 255, 255. Okay. Save first. Yes. Click one. Okay, why cannot? Internet. Okay. You go to big reading off. Yes. Do this one. Oh, internet. Okay. What is it? Can you bring it down here? No, bring it down. What we do? You minimize this. We open from the previous program setting. You minimize this one. No. Minimize. Go to your folder.
open your, yeah, yes. We check from here, we do the setting. Okay. Go to CPU. This is CPU, right? Okay. Go to internet port. Okay. Internet. Okay, they say network 4, right? Okay, see? Network 4 is the go down. Under yes. Double click. Okay. We bring it down here. So go to configuration. So you just configure this one. Then here, under here, you need to choose the internet. So you minimize this. You do the same thing. Open your previous one. Yes. Okay. So because we are here, we already add internet 1 already, right?
Yeah.
Right. Okay. Go up. Go to open configuration. Open here. Plus, okay, plus the CPU, Ethernet, choose here, TCP/IP, the link, white only. Okay, go down, and it means the setup is not full. We check. This one disable. We go to the other one. Go to security. Oh, enable. Open another one. So you enable this. Then IP configuration. Then pulang. Ethernet. You check another one. Messaging, nothing. SNMP, SNMP is nothing. Okay, go to same thing. Okay, go to the okay, messaging, nothing. SNMP, nothing. Okay, you go to build, analyze project. Or build project. We did all project. Yes. Okay, the tool is not ready. Internet one. It shows the tool is not ready. Why? This one you check and see, is it correct? Oh. No, CPU, yes. Okay, yes. Okay, now go up. See, internet port. Select. Now on. Okay, now you read it on. Not because of this, but because of this. Enter. Because of this. Click here. Okay. Then you choose this. You choose back this. Okay. Save. 200 Ethernet. Which one is 00? Okay, clear. module address, right?
Yeah.
Security. Go down. Is there anything else? No. Okay. Configuration. Okay. Then go to messaging. Okay. SNIP. Because admin all is let's say using for web servers. Okay, we click the new project. File new. Okay, no need to save. Okay. And close it. Ethernet. Okay, now what you do, you delete this Ethernet. No, not this one. Go down. Okay, delete this Ethernet. Delete. Yes. Okay. Now you go to file. No. You build first. Build it all. Yes. Okay, the tool is not ready. Go up. Go to this Ethernet one. Yes. No, the Ethernet. Open. Yeah. You don't. I don't want this. Yes. Okay. Save. Okay. Reveal all. Reveal all. We use the USB first.
USB.
Check using USB. Make sure all working. Everything and we get a new project. We go to build. Reveal all. Yes. Don't have nothing. Huh? Go to PLC. Set address. Use USB. Okay. Then the address you just go to the system. Yes. Connection test. Okay. You okay? Okay, connect. Okay, PLC is stop mode. Okay. Try to download. Wait, before that, you just have to try to download, right? Okay. Click compact. PLC and project are different. PC project, PLC project. Transfer project to PLCs. Okay. There is no configuration cannot be identified. Okay. Go to run. PLC. Run. Yes. Yes. Run mode. Huh? All working. No issue. Only the configuration discussion. Okay, now when we go to our program. Okay. Okay, it's already connected, right? Okay, you click here. Double click. Okay, close. Because I want to right click. Modify value, set value to 0. Okay, then this one set value to 1. Start button. Okay, see the bottom one. Set value to 0. name, we can know already whether it's the on or off. Because it changed color, green color, right? Now this one go to PLC. This one. We create a new project. Yes. You want to save? Yes. Save, you create a new project. Then they want lesson 2 lah. Then we do the configuration. Then we do the Ethernet first. Do settings first. Then go down, go to communication, network, right click and network, Ethernet, Ethernet 1, again go to command, go to commands, go to Ethernet, network, okay, go to Ethernet, click here, choose your CPU, this one right? CPU 2020 version 2.0. How to know this one? Okay, click yes. Then this one actually not an issue. You set the IP address. Done. Save first. First. Okay, go to here. Ethernet. Go down. Okay, motors. Then go to channel 3. Choose here. IP, link, Ethernet, okay. Go down. Why? Again, go up. You are missing something. Go to PLC first. You build. Reveal. Then you choose the other one. Yes. Okay. Then you go to PLC. So do you see the X mark here? Because check the you need to do something. Okay, go to tools. Oh, this one is it correct? What is your version?
From where?
I think from the hardware. It's not here. I think so it should be inside this. So it's a P342020, right? Okay, then there's some versions, right? You look for in the your upload file. And use the 3.2. Maybe this is it new one? Not new. How long already?
Since 2021.
Oh. Maybe my software, because my software is on the new version. Go to that. And thing is about EcoStruxure. Version 14.1. But because now I think version 16 or 17.
Let me check mine.
Yeah, check yours. And then I think you set up your laptop also. You see, if your laptop is okay, then you can use your laptop. But I think shouldn't be an issue lah, because USB can download, right?
Yeah.
Because mine got some error coming out, like, I don't know whether that one is the one. Because I see the videos also, they do the same thing. So So they just go here, add the Ethernet, then they choose the correct one. Close.
Just straightforward.
Yeah, let's say close.
Yes.
You close this one. Yeah. Then you go to Ethernet. Then you choose this one because ours is version 2 above, right? Because you click here, because this one is 1.0, then ours is the CPU, not NOE, right? CPU, because NOE is for Ethernet module. If you're doing for Ethernet module, that is for NOE lah. CPU is two type lah. One is 1.0, another one is 2.0 above. So we choose the correct one. Only thing is this is the not same thing, right?
Yeah.
Okay. But the rest of you just do the same thing. You can still can do. Okay. Try it. Hey man, you do what you do. You click the setup first. Control X. And you have machine export also.
Yeah.
All license.
Yeah, all license. Because we also use M241
Machine export is also similar to this. Code also.
Yeah.
You also using export Excel.
Yeah.
You create a new file, and you try to create all the addresses, and you try to do the networking. Okay, you see here, check this.
Also 14.
14.1, right? Okay. So, close. So if I ask you, do you want to save the setting or not? Let's say for example, let's say right. You see, validate, yes. Yes. So now it's closed. No, it's not connected now. So here also do the setting, same thing. Okay, let's say I do this one. Okay. Service close. So done. Just put on my pages lah. Okay, then when I choose this, once done setting again, close. This now it asks you to validate. Then if I want to use here channel 3, done, close. Do you want to validate? Yes. Then can you see? Yes. Cross mark. That's it.
Let's say.
You say in the video, it's not showing this. You just click. Okay, all done. Then actually I just only close this. Try to just close and see. Suddenly validate. Okay, so you change the IP address. No, what do? You close this. Close, yeah. Because this one is upload. No, only this. Okay. Not this one. This one can minimize that. But this one is upload one, right?
Yeah.
You can use as some reference. Okay, minimize it. You go to Onsite, the day 1 lesson 1. Others all will be like automatic save, like your backups. Okay, look, because that's not I want to hit because of this one or what. This is our setting. Okay, this is our program, right? Okay, go to network. Networks. Add the network. New. Internet, very straightforward. Keep looking. Yes. Open. Okay. No need to do anything here. Just go here. I mean, this was change this to CPU first. CPU first. Okay. Yes. Okay. So now there's nothing to do. Go to IP configuration. Okay, you set the IP address.
Okay, so cross.
Yes. Okay, do you want to accept? Yes. Okay, now go up, go to Ethernet, choose the Ethernet, Ethernet 1, okay, close, yes. Now go down. So what we do, we must use USB to download. After download, we disconnect, then we connect using Ethernet. Okay, so go to save first. That's the problem when you don't have the hardware, right? You don't have, because I don't have the hardware, so I don't have this, the hardware, what they call, hands on with the hardware, because in the program, because before when you request for this training, what I do, I just install the software in my laptop, just do simulation and everything. So I didn't use the internet. Because using simulation only, only internet, so I don't face the real issue. So when you have the real hardware, then only you face this issue. Okay, now go to PLC, set address. Okay, it's USB. Okay, leave it USB. Test connection. Okay, okay. Because I now I cannot use IP to connect because my PLC don't have IP now. Okay, go to PLC, connect. Not build. Okay, you build first. Build. Okay. Then go to PLC. Because if I connect ready, then I cannot build. Okay, now transfer project to PLCs. Transfer. Project is not built. Okay. Cancel. Why I can? Cancel. Go to build. Disconnect first. Okay, go to build. Reveal all project. Yes. Yes. Okay, one warning. Has been enabled because long overall disable potential failure is a real mode to support this feature. Okay, never mind. Because no problem. Because you click here. Yeah. Because this one we disable, right? Okay, so no problem because this service can be disabled only on CPU firmware 2.6 above. So we already 3.3, so not an issue. So warning always can whatever can download. Now connect. So make sure always build before download. Connect. Okay, it's connected. Okay, now transfer. Yes. 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 Confirm run. Now the PLC run happening. Now go to PLC. Disconnect. Yes. Then go to PLC. Set address. Choose Ethernet. Test connection. Okay. Click OK. Now connect. Yes. Connected. So now I can remove the USB. Okay. Alright. Any question until here? So far so good. Okay. But I don't think so we can use your actual PLC much lah because no input-output address, right?
Yeah.
Okay, but we can do some programming. You disconnect, you do some programming. Have you done any programming inside? No, just upload the line. Just make up. Go down. Go to ladder. Yeah, motor control. Okay. Let's say I want to start motor on, right? But no choice lah, we don't have push button and everything. So whenever we test, we need to test that. Right click set on, right click set off. Okay. You click, you add here, normally open. Motor. Double click. Motor. Okay. Then the time. Okay. So at the TON, TOF and the TP lah. So TON. Yeah. Okay. Okay, now what do you do at the motor here, right? Just delete enter. Okay. I think cancel. Okay. Then this motor bring it down here. Yes. Okay. So must enable. No. Enable no. Input. Enable or input? Okay, never mind. Let's try and see. Then PT is the timer. Click here. Now you key in here T hashtag. This hashtag 15 as okay. Yes.
This one is the format.
The format.
So every time I need to input a second.
Second is yes. This one can go up to okay. Good to have. I want to see. What is this? Go to index. Let's see, it's showing all the function. Okay, click UN. Okay, yes. UN. Yes, okay. It's done. So in function block is this way. Oh, this one need to enable, need to line the line here. Okay, then output again, go down. This one in what instruction is this? Structure text. Okay. Time. Okay, so it's in time now. So normally all these functions, I mean about your functions, right? You can get the data, details of your functions. So in input must be boolean. That's why we put normally open. So PT must be time. So that's why the format is a T hashtag. Okay? Okay, go down to see any example. Oh, no example. Because the example go up. Actually got example on top, but they didn't give you the hashtag. So that one is a standard lah for TON. Okay? So can go up to, because the time means it's a double integer. Okay? Double integer. So it can go up to 2 billion. That is 2 billion. Because if you're using in integers, 1 is equal to 1 millisecond. But now it's in time lah, right? Okay? So it means it can go up to 22 or 23 days. You can key in there. So T hashtag 22D, then let's say 10 hours. So 10H, then 10 minutes, 10 seconds, 10 milliseconds. Can go up to that. Yes, maximum. So can you use a day, hour, minute, second, millisecond. Okay. So anything you want to know can get from here also. So many from this one. Transferring everything they show you. Analog settings. This one. Yeah. Let's put this one. Yours is BMX, right? BMX analog, right? Okay, go up. This one. Anything lah, just click. So they show you how it works. Okay, go down. Allow you select between 4 page of current. Okay, go down. Okay, this is the lower upper range. Okay, go down. So nominal range means if 0 to 10 volt, in your PLC you will get 0 to 10,000. This one you can do actually, because you have an output, right? Yeah, you can do. But do you bring the connector on top?
I have
Okay, now because analog power, you need to give the supply. Not mistaken. We check the wiring. We try to get some data.
okay.
So 0 to 10,000. Okay, now this one later. So all that is here. So you don't need to download additional manuals for this. Okay. here, click here, then enable, you need to put online here. No, no, the motor must be in the input. Yeah, here must be just one line here. So must enable this. Yes, okay. Then you put anomaly close here. Okay, first we test this first. We see whether timer can run or not. Okay, you build. Yes. Okay, then download. Connect and download. Connect and transfer. Because some PLC they call download. So I normally use the term download. Download, upload. Download, upload, online, offline. Because all PLC are similar, but here they call connect. Right? Okay. All red means is off. Now you right click, modify the set. Set to 1. Okay. Oh, in stop mode. Okay, you go off mode. Run. Yes. Okay. Okay, you off. Modify to 0. Mean set to 0. So you see. Okay. Can you see after 10 seconds the cue on? That is a function of the timer. Okay, very simple. TON means timer on delay. It means whenever the input is on, timer will start to count. After I reach my set point, the output will on. Okay. Now I can use the output to off the motor. For example, you go to PLC. Wait a minute. Do online and click here. Right click. You click here. Normally close. You try to add normally close there. Do you confirm the one? Yes. Okay. You add here. Escape. Double click. You click here. Can you see? So you click here. This one. Okay. Yes, yes. I want to create an internal memory. That is an internal variable. I don't want to use any memory variables. Okay. Close. You go to variables. Just key in here. Motor off. Motor underscore off. Okay. Just put in no money, no address. Okay. So this is called they call internal variable or temporary variables. Okay. Go back to the motor control. Now I want to use that. Okay. How? Motor off. Okay, okay, because I want to check whether the variable is what I want. Okay. You rebuild. Rebuild changes here. Yes. Okay, can you see? It's automatic transfer. Because just now I do this when it's online. So it means like online edit. Okay. But I just want to check. Okay, never mind. So you can go. So what you do, you click, you add one, because after the timer, I wanted the motor off, put here at the queue. Then later on I can use it. Okay. So you add a output. So just now I put it here only because I want to check the online ID. Yeah. Okay, click here. Okay, we want to confirm yes. Put it here, right?
Yeah.
That's right. Okay. Now double click here. You put the motor off. Okay. Done. Because you see, it's still online, right? So when you build, that's why there's no rebuild on. You build the changes. Yes. So when you build, so it's downloading. So for this, you need to like offline download and you see it's off already motor. Okay, now what you do, we test again. You go to start, you on and off. On, okay, off back. Yes. So motor run after 15 seconds, this memory off, right? So it will off the motor. So that is the function of this time. So whenever you want to troubleshoot something like this, right? So let's say you don't know what is this. Just go to the help just now, right? Help. Just type in what is the function they use. Just check how to use these functions.
This PT is
the elapsed time, means the timer running. When we use the HMI, then we can you see this M340. What HMI using? In your 46
GXU something. I mean
Schneider one.
Schneider.
Because here I don't have Schneider, but I have the WinTech HMI. So we see whether the WinTech can use the WinTech. You disconnect. Go to tools. You right click here, variables, export. Tools, project setting, oh, no, cancel. Go to tools. Is there any project setting? Go to project setting. PLC embedded data. Here, use data dictionary. Data dictionary. Can check this. Okay. Export. here you can use. Because I checked your this one, because must export and import. So when you export all data, then in the HMI you import. So just put the one button and can use it. I'm trying to do this and see.
But my training course also include HMI. Right?
Yeah, of course.
So we'll be using the
Reviews using this filter. You are using what model is it?
Schneider model GXU something.
GXU. GXU 355 something.
Yeah.
Using what software?
Forgot the name. Not this software.
Not this software, right? Visual designer.
Yeah. Video.
Alright, this one we have a data access.
Okay.
And you can use HMI. Because if you're using the visual designer also, it's the same thing. You need to export, then you need to import, then you can use. Okay? So any question until here
No.
so far? So yeah.
Okay.
So the internet you understand, right? Just now the silly mistake. We didn't close the one.
Yeah.
It's supposed to it's like save lah, right? So that's why whenever we do this one, right, I ask you to save, right? But cannot save because we cannot. It didn't close.
Yeah.
I thought doing here save then can go. Oh, can close. Actually, can use simulation also. Okay, you disconnect the right. Okay. You build first. Bring it up. Yes. Okay. Then one warning. Okay, go there. Go to PLC. Simulation mode.
Standard mode is for
Standard mode. Click standard mode. This one is standard mode. You go to simulation mode. Simulation. Now it's simulation mode. So whatever, it becomes this one display. So now you convert. I mean you build it all. Yes. Okay. Then go to PLC. One set address. So it says now simulator. So this is be your simulation. Okay, simulator is 19127 lah. We follow this. Okay. Test communication. Test connection. Okay, now close it. Delete. Okay. Now go to PLC. Connect. Password. First you click on the one. Okay.
one we can simulate directly.
This can use the software itself. Control expert simulator. It's automatically installed together with the module as well. Go to services. Go to file. Number one, so you have ready. Domain, view, domain, also full screen windows. Domain, view, domain, yes, simulation, debug. Window, see later how to simulate this one as well. You click. Oh, that is a simulator. Starting it does not exit. Whatever the situation. On it. Simulated panel option. Password control. Simulation not installed or something. Later you check in your laptop for the simulation is working. Okay, then whatever you done is safe. Then we go for our break. Then after the break we see lah.
Okay.
Okay, simulation. This is just showing the right panel to the control.
What is that? Below R, ELX.
Pulse. The P and N function. Pulse, the main thing lah. At the same time, we learn other functions also lah. Okay, can you go for your break?
Can I make this?
Yeah, of course. Nobody is. So if you want to go to Mama shop, when you go down at the back, so this is the building, right? At the back, there's another building, behind lah. Then you just the road. Okay, behind this, I'll just show you. So this is our building, right? Okay, this is the main road, right? Here is our building at the back. So we are here. So the road will go like this. Okay. Then this is the main road. This is the small road lah. Go and join here. This one is the road. So here also same type of building lah. Okay. Here one. Just I hope you can understand this one. So we just go this way along this small road. We go here. Here one shop lah, one Indian shop also. Here go here will be a hotel.
Or the leverage.
Leverage. Okay. In front of the hotel, here's the mama shop.
Oh, okay.
So just two building lah. This one building is our building. Here also there. Here one building lah. All these are our shop lah. In front of the hotel.
Okay.
Just like one retail plus.
Okay, thank you.
Okay.
See you.
Alright. And the side, you press at the side here. This side, this side. Yeah. Okay. Okay. Yeah, MPS. Is it far? Okay, right.
Sorry?
Is it far?
No,
Oh, no.
around 200.
Yeah.
Bisa lihat untuk masuk.
1, 2. Go to standard code. Go to PLC. Standard codes. Okay. So go to your PLC, right? So we continue with some other functions first, huh?
Okay.
So we can close these. Okay. Now, so motor control. Okay, so this is the timer, right? Timer with the off the motor. Go to variables. Okay, actually you can just use the all internal variables only also can. Okay. Now, when okay, actually this and this actually same thing. Okay, it's a similar thing because it's a memory, right? It's an internal variable. When we use this, okay. So this memory with the address, right? Okay, we will be using when we want to use some HMI. Because we want to link with the HMI, right? We need the address. This one is when we do not using the HMI, right? Then we can use this also. So not necessarily all the memory must use M. So because this one also can work, this one also can work. Right? Most important the input and the start, the input outputs. Okay, but we cannot add now here. But later you check with your PLC the simulation working or not. If working, then in your laptop then we can add some IO. We can do some programming. Because there's not a check also. The simulation is not working. You need to reinstall the software. Okay, so we add some additional memories. Okay, so what we do? First, we learn some function first, a few functions, then we try to do some program or project. Okay. Start, stop. Because it's already controlled here, right? Maybe you can add a start M1. So we can just use the internal memory lah. Only to use the M. Okay. Internal variables. Okay. Stop M1. Then motor 1. Then what else? Stop. Johor because. Okay. Nah, later on to add we can add. So now go down. So you can continue here, or you want to click another one also. Actually, okay. So we click another one. Right click here, new section. Motor, no, set reset. Then the language ladder. Use the normally open start. Start M1. Here we are. Start M1. Okay. Then the output, use the set. No, the S.
Oh, set.
Yes. Okay. Then add a motor 1. So this one set means it's like a latch. It's like a holding lah. Okay. So it's like this. So just now we did something like this, right? Start. Then motor, right? So this is a. So we call it as a coil, right? Okay. So how because whenever you on the line become green color, right? So this one similar to your like single line diagram, like your wiring diagram, right? When this one on, here it gives the signal. So this is the coil. Coil is always referred to your line. If the line is 1, your coil become 1. If line is 0, coil is 1. So that's because this is a push button, right? You on and off. So that's why we doing a holding, or we do the latching, called latching or holding lah. Okay. But set, it means it's already a latch inside, because set is they call set coil. So let's say start. This is a motor 1. So I no need to do the holding, because one here I give one pulse enough. Just one pulse enough. It always set, always on. Okay. So for this, if I want to off this, means I need to cut off the latching. So you can put normally close stop button, normally close or normally open, depend on your switch. Let's say your physical switch is normally open, then here will be normally close. Because normally close lah. So when you press it become 1 pen. So normally close will become 1, you can open. So something. So that one is what opposite way like work. Okay. In this case, I cannot do this. So I need to reset this. So I stop 1, reset motor. Okay. And in the same project, in the same PLC, even I do multiple logics, right? I cannot repeat the same output. It means, for example, here I use this motor 1, right? I can do it again motor 1. We'll have a conflict. Okay? We'll have a conflict. So some PLC, but it won't give you error. Means you can do that, no problem. The logic is, the PLC can accept the logic. Okay, so that's why it won't give you error. But if you do some wrong programming, it will have a conflict. Okay, so for example, I press start, let's say this is motor 1. So let's say the same program, I press this start button, okay, motor on. And again like I stop, then again I press this start button, I want to on the same motor. If I do a correct program, then it works. In this case, it can work. You know why? Because the moment I press start, motor on, and I latch it. So holding, okay? Then I can stop. If let's say I on this one, so simply, when I on, this motor on, right? Then this one on means here also on. So it can go. You know why? Because the PLC will top to up, up and down is scanning. Let's say I didn't do this here. If I do this one right, so if I press start, the motor cannot work. Cannot on. Even though here is set. You know why? Because how it works. Let's say I press on, right? The signal goes here, then on here. Then the PLC come here and see. So not on, right? So it cannot energize. So what happened? It will off. Okay. Same thing goes for here also. So if I press start here, I put set. That means must hold, right? Actually, it's hold here. Actually hold, but you see. Then PLC after scan this one, PLC go to here. PLC will scan this program. At that time, still set. But the moment PLC go here and see this one not on. So I cannot on now, right? So off here. So it's actually inside, according to the theory, inside PLC program actually is on here. But the moment PLC go to next here and scan here, it will off.
So this conflict.
Yes. But if you do a correct program, then it's okay. Because why? Because the moment I press on, here also on. But it won't give the signal yet. Then PLC go here and scan. When the PLC come here and scan, then PLC go here and scan. Then only it will connect. So that's why. That's why. So whenever you have a set or something, a set of coil, even I do multiple coils, same thing. We have a conflict. You know why? Because you see, I have only one motor. But in the program, I create multiple coils. It's possible, no problem. But if I convert this into a wiring diagram, I cannot have multiple relay for one motor. Right, only one relay for one motor. Right, so same concept. Okay. But if you do correct program, then it's acceptable. That's why if I do repeat like this, some PLC they don't even give you warning. Some PLC give you warning. Omron and really all will give you warning. It will show you duplicate output. So because you're using, because some PLC if you use this one also it will show duplicate output. Some PLC set reset because output 2 times right. But it's still acceptable. Because if you see some videos they teaching programming and they say this one you cannot do this one or cannot do 2 times, means can do if your program is a proper program, can work. So the best way is don't do this. If let's say there's another input on the same motor, just add here. So I'm doing this. So let's say start right, start on. So means the concept is when I press this start, the motor need to on. When I press the start one, also motor need. Because that is logic, right? Then, okay. For reset, reset multiple place I use no problem. Multiple place no problem. Okay. Then, if I using normal coil and I want to reset I said, you can do program, say sensor, motor 1, I latch this motor 1, means this program can work, right? Can work, okay? By logic, can work, no problem, not an issue. Because here I already latched. But why the programmer don't do this way? Because difficult to troubleshoot. Okay, this program can work, no problem. But why the programmer don't do this way? The programmer only use one time. Okay, why? Because difficult to troubleshoot. Why? Because let's say the motor is not working now. So we go into the program and we want to see, okay, why the motor. Of course, we will see the logic, right? Of course, here we have multiple interlocks, correct or not? Like this, also like this, right? So now for so many interlocks, now we don't know where is the problem. Difficult to tell whether why the motor 1 is not on because of this logic or this logic. Difficult to see sometimes because cannot monitor. So you have two places. Maybe this one is in the first line, this one is in 20th line. Difficult to see. So the best way is any interlocks want to control this motor 1, make it into one line. Or because all these are based on my experience in doing programming and also troubleshooting. Or you can create a memory here. Maybe so this is one set of interlocks, right? For example, okay, this is I just put M1 on, for example. Then here another set of interlocks. M1 on 2 on 1, for example. Okay. Then here one set, here one set. Then now I use this M1 on 1. Now the motor 1 output. Now the actual output. Or M1 on 2. So when you troubleshoot, of course, this is called reverse engineering. So whenever you troubleshoot from the output. You go for the input. Whenever you write a program, from the input, you write the output. So when you see here, then from here itself, you know already which one is the problem. Whether this one or this one. So let's say this is from here, I didn't get the signal. Then I check why the problem. Then I troubleshoot. If from this one, I troubleshoot this one. Okay. This one, because PLC is basically creating multiple interlocks to run a system, right? Safety systems. Because even your system, yours is water treatment, right? So water treatment, of course, you will have pump, valve, mixer, then pH value, pH value, then what else? Level meter, right? Level meter, you can check the pH. So yours is basically treatment, right? Water treatment, right? Okay. So, and what else?
pH, NTU, turbidity. That one is for water quality.
Water quality.
Monitoring.
So all these are okay. Then so many interlocks, then only you can on pump, on mixer, right? So we'll have so many interlocks, like your program is just not using so many interlocks. Okay. So if I using a step, if I want to off this motor, I must use reset. If coil, then I can use interlock like this or reset also. If I'm using a normal coil. But if I'm using a set, must use a reset. Okay, so you add a stop. Normally we put this stop and one. Okay, then reset this. Motor one. Okay. Alright. Okay. You save and build. completely. Okay. Now can PLC down. Can transfer. No need to connect and transfer. Right? So no need to actually. Well, if you want to set address, right? Set address means just to choose what is the communication. Okay. So when you want to set address, is it power off? No. Check your internet, laptop internet. Okay. Enter PLC transfer project. Okay, transfer. Okay, go to run. Right click. Set on. On back. Okay. On. Okay, what happened? Is it your motor is on or off? Motor 1. Actually it's off, right? Green color, right? Okay, so if the address is on or off, we can see from the color. Now it's off, but you see here, it's still the set is on. Right? Okay, but why cannot on? Supposed to set also, right? Okay, but so what happened actually here? When here on, here also on means now currently inside your PLC, the motor one actually is like on off on off on off on off on off on off because scanning one. When PLC scan here on, when PLC scan here on, but this is the scanning is very fast. Right? So since it's very fast, we only can visibly can see the off. Some PLC only in the program because now we don't have an actual output lah. Some PLC if you have an actual output, you can see the output. If you connect a lamp lah, suddenly a small blink you can see, especially in LMW. Other PLCs you can see. LMW suddenly you can see like small blink. It means inside the PLC is like on off because that is the theory. The theory is one by one it work, but it's very fast. Okay, so when we do program or when we troubleshoot, so you make sure when it is set reset. Okay, so we need to make sure both are on or one. So in this case, what we do? So because I treat this as a push button, so it's supposed to be on and off button. Like a push button. Okay, so on, off button. Okay, but because we don't have an actual push button, right? So what we do, we can. Okay, this is the one. Okay, we can use the pulse function.
Pulse.
Just give you one pulse. Okay. So if you want to on again, you must off and on again. Okay. What do you do? Just take this P and no, put it here. Yes. Are you sure replace this? Okay, I want to replace. Yes. Okay. Same goes for your this one. Yes. Okay. It means P means it's a positive pulse. That means just now I set to 1, right? Means from 0 become 1. It just give you a pulse on this. Okay. Then you escape you because we did online edit, right? Okay. Rebuild. Build changes, yes. So build changes means it's only build the changes. Download the changes part. So but this button is still on, right? Okay, you off this button, set 0, okay, so set 0. Oh, now this one set 1. Yes, can you see? This one not on by my output. But you can see this line green. But actually my motor is now running. Same goes for your stop. So stop also. So from 0 become 1. Yes. So that is the pulse. Normally open is just always give you 0. Pulse means it just give you like one pulse only. That one also got P and N. P means from 0 become 1, then I give pulse. N means from 1 become 0, then I give pulse. Okay? Good? Any question until here? So far okay, yeah? So what I want to do actually, normally day 2 only I will start the HMI. But today I want to do day 1 because we don't have push button to play around. So we can create a button like start, stop buttons, everything in the HMI. So easy to on off, all that. Okay? Alright, so this one first, we set up the HMI first.
I think firstly we face the issue, maybe setting it close first.
Yeah. Yes. Need to close. We didn't purchase. First initially it shows there's no configuration, right? So after we configure, also still it shows not ready. Yes. Need to close. Is it online? You disconnect. Because I checked in the YouTube for video for this tool, so we need to test it out by ourselves. Because in the YouTube for video of this and this one don't have, so try it. But this Wintech is actually straightforward. Wintech, yes, it's a China model, but it's very user friendly.
So the software is
Easy Build. Sorry. Easy Build Pro, yeah. So what we need to do is
This one, right?
Yes. Okay. That one don't have clip, no problem. Because the clip side I put it is here.
Try to connect.
Can I connect?
This, yeah.
Oh, now
Easy,
okay.
easy, easy.
No, 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 now okay. Now you should try. You shall try again.
Okay.
Because just now got error because we remove this right, so it cannot communicate with the PLC. That's why got error. Because why? We configure this, we configure Ethernet, Ethernet communication. So when there's no Ethernet communication, it shows the error.
Okay.
Okay. Now what we do? We change this IP address. So to change this IP address, this HMI this is the setting lah. So the IP address you change to similar to this. So your CPU is PS4, PC is 10 20 20 10. Your HMI you put 10 20 20 20. We sometimes use the use your nail. Nail easy. Can close it. Yeah. So, okay, okay. Alright, okay. Try. That's the first time doing it.
So currently you are the only trainer lah. Yeah.
Yes.
Or Mr. Yoks.
Emo on IT.
Oh.
PLC, I'm doing training for PLC. Emo on IT and management. 2% of it. But last time my boss here. So when my boss is here, so he do the training mostly. So I just support him on trainings. Just prepare all these connection and everything. Then I just concentrate on other works like project or troubleshoot or any servicing like that. If I don't have anything, if I'm free, then I do training. I joined here actually 2016 or 2016. Then 2019 all I slowly start to give training. Support my boss. Okay. Then 2020 2020 of course. Not doing any training already because COVID right. Then but during that time also I do training on online because that time in 2020 starting January we conduct training for Indonesia because there's a company from Indonesia, you know the Philips brand right? So there's a company in Indonesia, Batam. Yeah, Batam is near to Singapore. So actually every weekend they will come here for training. Like 3 weeks like for one PLC course, 3 weeks. Because near only. From here, from Batam to Malaysia, like 1 hour ferry.
Ferry.
Ferry, 1 hour ferry, very near. So from the jetty to here is around half an hour. So normally they will come on Friday after their work evening they will come and then they will stay at Leverage here. Leverage. Then Saturday morning, Sunday. Then Sunday around 4 o'clock all they will finish the class. Then they will go to jetty, then they will take the ferry lah. So actually every year they will send like 4 batch, 5 batch, each batch like 4 bags like that. Then what happened during COVID time, just before COVID they was doing training. I was doing, because before that they, in just 2019, end of 2019 they already buy a training kit from us. So we also sell training kits lah.
What brand?
I sell, they request for 4 brands. Siemens, one for this one, so this with the analog input output, and the HMI, small HMI, then a potential meter for analog and voltmeter lah for output, then some switches lah. Then because I use this kind of, it's like a suitcase. You know the case you can open, so when you open the PLC will be here.
Yeah.
So they ordered this, then they ordered the Omron, the new Omron with HMI. They ordered the back off only PLC, no HMI. Because back off only HMI because the software itself can do visualization. Then they ordered Mitsubishi with the servo motor. So each brand they ordered 2 units. So we finished everything, we sent to them. Then 2020 I start do online training. They say they don't want to come here, they want to do online. Because they already have to, last time they come here because they don't have the hardware, right? So they are online. Just COVID then finish. Cannot continue. Because they also COVID. So after I think 3 or 4 months, then I continue back. But go online. Then from there I started to do gift training and the.
But at your side, you're using what PLC?
Depends. So Omron means they will use Omron training. For Omron training they will use Omron PLC. So they will have like 4 packs. So 2 person will share 1 hardware. 2 person will share 1 hardware. So here I just do the Microsoft Teams. Just share the screen. So but it's difficult for me. You know why? Because for this one, for like this one, I connect yours and I show you here. So I will follow your speed. How speed I do, operating the software. If online means I need to show, right? So sometimes very fast. So I'm very difficult. So what I do, I just show a few things, then ask them to give project. I give small project. Okay, just show them. Okay, now we open timer. Okay, do project. Now we open set reset, do project. And 2021 all, then my boss retired. Then we started to do face-to-face training. Now every week of training. Because why? Because we even start training with 1 max. Some company they don't do that. Some training provider they must have minimum 4 packs. So we don't do that. So if you want 1 pack, okay, I do it. That's why nowadays I cannot do projects. Nowadays I have project, but I do like afterward. Back. So I do take big projects. I just take like small projects. Mainly the programming only. I don't do hands-on very rare. There's no time. So programming means okay when I go back and Saturday, Sunday or night time I do programming. Okay, now what I want to do, because I also never done before. So try, okay, go to PLC disconnect. Okay, now what you do, we write in the variables, for instance, export. XSY, choose XSY. Go to your folder. Okay. This one is what? Day 1 lesson. Maybe you can inside your folder you can create another file later. Day 1 L1. just put HMI variable. Yeah. So easy. Okay, open. Okay, export. Okay. Zero error, zero. So okay. Now minimize this. Minimize this. Okay, minimize this. Now easy builder pro. That is HMI. Oh, so many brands can use. Yeah, I think
Wintec also have a on drive, right? If I'm not mistaken.
drives, I'm not sure.
I think I've seen their vendor before, their exhibition in our Asia Wonder exhibition.
Wintec drive does not exist. Maybe another, maybe different model. But Wintec, I know they only support only HMI because they moved to HMI cloud programming. Because this can do cloud programming. They have their own cloud, Win cloud. So you can create a HMI here. Then you connect this to your internet. Then you create a login to a cloud.
But they run a subscription.
Substitute. Yes. Subscribe because they don't know. If not mistaken, they don't have like free runtime. Right. But it's okay, not expensive. You can buy a China license. I think it's around. They have to have China and US. So China license, I think, because China license depend on the number of tags lives. So you can create. Then from your house also, you just go to your cloud, log in, you can see the same. The good thing is, you know what happened. This one be connected to example. This is in your company. Connect the HMI to the cloud, but must have internet lah, of course. Connect everything. Because this HMI come with Wi-Fi, some need to connect LAN. The good thing is the internet, the HMI can have they call easy access. Means from my house, I use the cloud and I connect to your HMI. Then so it's already do the connection, right? Then I can use the control expert connect to your PLC. I've done before, but I never done this control expert lah. I'm done with the Siemens. Yes. So this so what happened? TM portal use HMI connection to do this connection. So from your house you can just go and modify and make.
Yeah,
Yes. Okay. So we use new. Okay. Can you see this one no Wi-Fi only some with the Wi-Fi. Not sure. This one EMT series. This one not expensive. Just click. This 37. CMT. Go down. This one got Wi-Fi. Like the server lah, this one. Resolution is the customizable. Means it's like a PC. Can use a PC. For that. Okay. Go up. Ours is this model. At the back you can see. MT8071 IP. Yeah. IP2. Okay. This is what I did. SCADA can use the HMI to pass through the PLC. Even you can use a SCADA, no need to directly connect to PLC. So normally SCADA is they directly connect to PLC, right? Here, no, here you can just connect from, take data from the HMI side. Okay, go up here, local, device new. Because I also first time doing. Okay, what we do, you click here, just click it. Then you click here, choose Schneider. You see, all these are PLC, not only PLC, PLC models and some controllers. So some is like a controller, not a programmable, it's like a direct controllers. Some drives, all these can connect. So Schneider electric, yeah, electrics. Yes. Then if you want to use the TM, you use the Modbus TCP. Yes. If you want to use the this one, you can use this. Okay. Okay. Now setting, go to setting. Okay. One, you key in the PLC IP address. And let me check M340. Okay, wait now. I want to know what is the port number for Schneider. Should be normally this one automatic. 50. Same like. Oh, 50. But this one is 10.
What number is?
Port number is for the specific port number for the for TCP connection. If you're using internet connection, so each PLC, different PLC, they have their own port number. So normally it will be automatically. So but just check on it here. Correct. Because you see, they said if you're using processor using Modbus, then you don't need port number. But if you're using normal TCP, port number is 50. Even Modbus also for 50. Yes. For this. Yes. Because yesterday evening I was just checking their manual. Just go through the manual. I see somewhere. I don't know where is the manual. Okay. Okay. So Ethernet. Okay, the most important part is this one. So symbolic address. Okay. Then import tag. So this now is XSY, right?
Yeah.
Okay. Open. Successful. Okay. Okay, now okay. Alright. Now go to project. So it's object. Let's put one lamp first. Okay, click here. Policy. But I want to check the lamp only first. Okay. Choose this motor first because this motor have a memory address. This motor don't have, right? Let me check this first. Okay. Just one now. So it is change color. Okay. Just put it here. Okay, save first. Save your folder. This is your folder. HMI variable. You can put under here also can, or you can create another one also. HMI. Yeah. Because why this one file itself will have a few files. So this HMI. And I can put day 1 and L1. Okay. Save. Okay. Go to project. download. Okay, wait. Before that, let me check. Can you do simulation? First, do online simulation. Online simulation with the software. Connect to your PLC. It's not complicated. Okay. Okay, good. Now, if I can see that this means it can work lah, but double check. Go here, go to your program. Which one? Go to PLC connect. Okay, then go to your first round, motor control. You on. Okay, see? Okay. Okay, can work. Successful. It's the first time I do. I never done it. But you know why I can do? Because the concept is same. It's similar like Siemens. So Siemens also same. You do the project, you must export the variables. So in the what Siemens they call it text. So you export the text. Then here you just need to add the PLC. You need to put the proper IP address. Then the port number. So port number also just now default lah. Just now just Google and check what is the port number for M340. What I search is Schneider M340 TCP IP port number. Because I'm not using the RTU. Because RTU means the 485. RS. So for that different port number or maybe different settings. So I just check. Okay. So can close. This one can close. Okay, the simulation. Close. Go back to the HMI. Yes. Then, okay, but we test with the actual first. Actual, so that okay, download. Okay, what is the HMI IP address? 10, 20, 20, 20, right?
Yeah.
Okay, download. Actually, I want to ask, is it can you give can you give us the PLC before the training? Before training, you can say like I request give me your PLC. I want to test first. Your company do that before the training?
I think I'm not sure. I need to ask my superior. Actually, for this training, me and my superior should come, but he cancel last minute.
Oh.
Yeah, supposedly we both of us will attend this training.
Okay. Because I wanted to ask this before training. Can you send us one? So because I don't have the hardware,
Yeah.
I can do some practice and can do some manuals and that. But I don't because some company they don't give. But last time the same thing. I have a request for one training. That is what? GE for no, if not mistaken. But that time we don't have GE for no. So they request. So then I asked them whether you can give me your PLC or not. I want to test. They say cannot. So then they said the same thing lah. During training they bring theirs, then I do training. After that only we buy that PLC. But it's the worst decision. You know what? Because my boss buy five set. But all second hand lah. But one set itself is around 5,000. PLC because that one come with the rack. Right?
This one is modular, right?
Yeah, modular. Similar like this one. So the buy 4 unit.
1 unit 5k.
One unit 5k, around 5k.
25 something.
Yeah, 4 unit, 4 unit. So around 18 to 20k. You know what happened? Last minute the company cancelled.
Why?
This was in 2019. That time my boss slowly upgrading on business. Then after that, I didn't do any training. Only last year I did training for 2 packs. Okay, so that's why if I wanted to buy something, I make sure I get a lot of requests on that. This Schneider also we buy because it's cheaper.
Yeah, this is cheap.
This one I think around 2000 something.
Yeah.
So last time also one company request for 2 packs. So I just buy one. So maybe in future got a lot of training coming and maybe I buy 2. Something like that. Siemens all I don't mind. Because you know every month I have Siemens. Every month. That's why this one Siemens I have full complete set. Like PLC, what model PLC you want from the Siemens, every model you have. The drive, HMI, HMI 2 different type HMI. So same goes for the Omron, Mitsubishi, all that. That's why Schneider we do because I check the price before. That's why very expensive.
Yeah, that's why it's
very
very
expensive. Then I see it's more expensive than the training. So maybe you see got lab with the HMI?
Yeah.
Got lab oh okay. So now easy to test lah. Okay. First I just show you okay, now you know how to create a lamp, right? Very simple. Then we go to object. Set B. Yes. Okay. So we choose here. Start. Yeah. Okay. No, I want to try. Okay, now I start first. Okay, now. Then you choose here. Momentary. Means like a push button. Like a push button. Set. Just now it's a set on means when I press, it will always on. Then I go to label. Use label. Yes. Then here I add content. Yes. Start. Okay. Okay. Same thing we do for stop also. Okay. And I want to add another one, the start M1. So I want to see the start M1 can use. Start. Because why? This one all got address, right? M0, M1, M10. So I don't have address. So I just want to check. Okay, go to save. Go to project. Okay. Actually, don't need to download. You can do simulation in easier. Just can test here itself. Okay. So what I want to do? Go to HMI, name the program. Go to the set reset. Okay. Go to HMI. You bring to this side. Okay. You press this button. Okay. Already. Okay. You press again. Yes. Can on the mode. You press and hold. You can see this one become green. Yes. So means you can use the without the memory also can use. Because why? Because we didn't do setting like start button M1, M2, no right? We export the tag, we import using the tags. I mean variables. So not an issue. Okay. Alright. So this is for the buttons, the lamps lah. Okay. Actually, you can do for values also. Okay, and close this. Close. Okay. Let's say if I add new tag, okay, how to update? Okay. Okay. This one, right? say I don't want to use this, I want to use a tagging. You click here, you just delete this one. Delete. You create a new name. Timer input. Okay. Yes. Okay. So, no variable, right?
Yeah.
Can you see? It asks you to create a variable. Is it data type is fine? Yes, of course fine. We cannot choose. Automatic. Okay, yes. Okay, then it will automatically go there. So go for others. Yeah. No. The output. The timer output. Yes, here. So you can add another name. Here. Not here. Yes, okay. Timer display. Okay, yes. Okay. Say, build first. Reveal all. Yes. Okay. So you straight away download because we are online, right? Okay. Oh, offline. Okay. So means you need to download later. But before that, what I want to do, I want to export again. Export. Right click the variables. No, variables. Export. Click here. I want to override this. Yes, export. Yes, override. Now go back to the HMI. Go to home. System parameters. Okay. Click on the this one, yes. Import tag. Oh, choose back the tag. Go back. Yes. Okay. Okay. Now go to object. So for values, you can use numeric. What's it? Time input. Can you see? It shows unsigned double. Okay. Click that. It's not the same one, right? Okay. Go to data entry format. So it's a 32-bit unsigned double, right? Double means 32-bit. Okay. Main thing is go to general again. Main thing is the allow input. Okay, okay. Just put somewhere here. Okay, then you can add a name. Just put the name. Then here you take timer input. This one no need a link. Okay. Put below that. Then you put a name, timer display. Okay. Actually, just see the video. Video designer also same concept. Need to import, but you don't need to export the tag there because the import it will import the whole project file. So when you want to import means when you choose import minimize. If you're using video designer, no need to export this. Just everything done, just save. Import from this file means you go to your folder, So if you're using video designer, go back. It will import from the SD. So you just same thing. In the video designer, there's under the variables, they have a variables. Just right click, import, choose this one, you import it. Okay, go back there. Done. Okay, now before that, you go to this one can test. Okay, go to this one project simulation online simulation. But I don't think so. No response. You know why? Because this tool tagging, right, is not inside the PLC.
Oh yeah.
Even now, that's why I just want to test. This one, right? Connect and you click here first. I don't know why it's becoming this. PLC transfer to run after. Yes. Okay. Okay, I think the timer value will be different, not mistaken. Okay. Okay, you click here. Okay, now you click the start. You click to this side. Okay, click press start. Start and pull. You open the simulation again. Close. Go to this save first. Okay, online simulation. One can be that one. Possible. All the time already. Please check what numbers. Click the start button. Go to your program. Here. Double click here. No cancel. No cancel. Okay. Click here. Start. The timer setting is I need to convert something lah. Okay, timer for now, timer never on it. First, go back to here. Okay, remove these two timer. Okay. Save. Then simulation again. Save. This is a local device. Orbit. Put down program. Here. Go offline. Go to internet.
But the programmation needs to be double here.
No need, because if that one, because if simulation not working, he also won't work. But you try it. I can download, yeah. First, without the timer first, okay, now. See, you can communicate with the HMI. See the HMI, you can communicate. Yeah. Can you see the lamp?
Yeah.
Lamp can see.
Thank you.
Lamp can see means it can work. Because if you know what, because if lamp cannot see means it cannot work. Can communicate. Go to your program. Go to your go to connect. Yes. See that, of course. First timer, no, you don't have timer, right? Okay, now you go back to the HMI. You add that timer. Just put one timer input here. Okay. Then allow input. Yes. Okay. Now we save transfer. Okay. Maybe the simulation here also, because this one also communicating here, right? The simulation here. Okay, now so you go to the program. What is it? Okay? Millisecond. I want to put in seconds. Means 10,000 lah. Later we transfer. You know why this happened? Okay, because of the data type differences. Okay? Because you see, in TON we have enable, in, PT, enable out, Q, AT. So here it's a boolean lah. This one is like always on, right? Here one boolean also. Okay. So here is a time. The data type. Correct?
Yeah.
So it's a time. But in the HMI, the data type is a unsigned double integer. So time format, right? This format is a T hashtag whatever value and the symbol. Correct? So can be a day, hour, minute, second, milliseconds. But double integer is just a value only, normal decimal number. So what happens when this value want to go here, right? So when you want to go here, so 1 is equal to 1 millisecond. So if you want to do conversion, I need to do some calculation. So for now, what you do in the HMI, you make it 5 digit. Now 4 digit only, right?
HMI.
Yes. Level 3. Go to format 4, right? So make it 5. Okay, it's okay. You add another one for timer display, you download. Should be same lah, fine. Okay. Save down. And name all later will put lah. So most important is can communicate. That is important lah. The name all no problem. Okay. So when you're doing a project or when you're doing settings, everything, right? If you want to screen record, because since I don't have the manual for this, right? You want to screen record, so
Oh yeah.
I have a screen record over here.
Yeah. Can I?
Yes, of course.
I think I will name this in case I forgot.
Yeah, of course. That's why I asked. Because normally, because if you see my slide, that slide for this
One. Yeah.
So I have how to create program,
Mm.
how to create a simple program.
Yeah.
Just how you see, right? How to create HMI, do the program. Because mainly is the settings that is important. Like what we do, like Ethernet setting, that one all important. So later on when you do project or thing, or when you want to learn, you just can screen record. So later on, because you bring the your laptop also, right? So this can confuse. If you have artists, you can go. Okay, so you see in your for me here you open your PLC program, the motor code. Okay. So now you press that. Okay, right? You can see the value also, the timer running.
Yeah.
So that is the ET. So now you ask me, right, what is ET?
Yeah.
So that is for the timer running. Okay, good. Any question? Until here.
So this one you can just
Can change timer input. So you can go 5 digit.
This one is 5 digit. Is for millisecond. So so 10 seconds.
10 seconds and 10,000. Yes. Correct. Just add another 3 zero lah. So later on we can do calculations over here. And if you press stop immediately, also you can cut off. Okay, you start stop. Stop. Yes. Okay. Good. Any question? So okay, okay. Because why I teach you the HMI? The HMI is very straightforward, right? Just the button and everything. Okay. Why? Because we don't have I/O. People less. No, can program but difficult. No, need to press the set on, set off. Right? Difficult to press any files. Okay. So now what we do? So we already learned some functions here.
Steven, so
Yes, yes.
I screen record using the slide.
No problem. No need. Okay, if you want to screen record, you minimize this. Close. Can close this one. This one. Mobile with screen record. So. That is record. So you need to choose. Just click like this. Just click enter. So it will entire one. Just click. Yes. So you select entire one. But if you cancel this, you cancel. Okay. Let's say you open your software. now you screen record. Sometimes it's just only record like this. So if you want to record the whole thing, just go to the end. Yes, it will record everything. Okay, just click that. Okay. Then click record. So once done, then everything.
So you will record this window only or the whole?
No, the whole window. You can try. You can go back. Go to this one. Yes. Okay, everything done. Okay. But the panel there is go. As you can click here. Minimize this. Where it goes. Yeah. Only you show it here. Okay, you click F10. Okay, F10 is a stop. I mean stop lah. So once done, you can just choose your folder where you want to save. Make sure your PLC. You can create one folder for video. Yes, you can save that. Select folder, yes. Save as, yeah. Yeah, something. No, I haven't done. Click this. Save. Close. Oh yeah, something wrong. Okay, we do again. Just click here, okay. Record. So you see, F9, F10. F9 is pause, F10 is record, okay. Just click here, okay. Then open this, okay. And click F10. Okay. I think better export here. I mean, try again your folder. Desktop. Okay. Select folder. Oh, something wrong. Then leave it to their files. Just videos. What are videos? Oh, yeah. Okay, select folder. So leave it there. Later on, you can open it. Okay. Just export. Oh, I think maybe here need to select. Oh, just now view files. Okay, sorry. Here I think need to select. Yeah. Okay. Yes. Okay, save. Finish. Show your folder. Yeah.
Okay.
Click export first, then you can choose.
Okay.
Yes. Okay. Now, what we do? We do a project. So far, so you get a new one, a totally new one. Yeah, close this. File and disconnect. Then you can go to file. Save. Are you recording now? want to pause, you pause. If you pause, it's F9. You click F9. Okay, you click F9 again, continue. Because it's not showing anything this one. You click F9. Not recording actually. Maybe you can close this one. Oh, but
I click F10.
oh, now can. Maybe just now cannot. Oh, okay. Okay, never mind. I can close only this one. Okay. Wait. I escape. Because I don't want to close this panel. Click here. Hide recording. I don't want to hide.
Yeah,
Oh, okay.
it's very safe.
Hide sense, yes. Because when it's like here, easy to see whether it's recording or not. Okay. Start record. Now you're doing new project. So whenever you are not doing something, just pause. Okay. We do the setting first. Okay? Alright. Yes, yeah. So easier. Because we are not going to do anything here, right?
Yeah.
Not clicking anything here. So just okay. So it's what? 2020, right?
Yeah.
Okay. Minimum is 3.2, right? And 12 slots. X BMX, huh?
X.
Okay, okay. Okay, cancel. Okay. Yes. Then you add the IO. Delete module. Supply is 3020. Okay. Then the analog AMO, yeah. Okay. Next. Finish already, right? Okay, close. Next setting is always finish means I think better close the down one. So maybe you save or something, right? Okay. Now go to the combination, right click new. Okay. Internet one, okay. Double click. So bring it down. Yes. Yes. So bring it down. Okay. So IP address 10 20 24, right? Okay. Then 244. Say 255. Finish. Next. Close. Yes. Okay. Still X, right? Okay. Because of it. Then it open Ethernet. Channel 3. Finish. Close. Yes. Okay. Finish. Okay. We go to build. Ready all projects. Okay. No error. One warning. What is the warning? Security. Security normally have warning. Okay. No, not the issue. Save first. Go to file. Save. You can put day 1. Project 1. Save. Okay. You maybe want to pause? Can pause. Yes. Until here. Now you want to do a project, right? So give it now. But make sure don't forget to continue later. Right?
Okay.
Okay. So the project is because we already done this, timer also we see, right? How to do. Set, we set also. Pulse also, right?
Yeah.
Okay. So from here, all these, I just put the pulse P and N. So from here, I don't follow any syllabus. I follow this. Any PLC because I know what it is. So first of all, from that, then of course the trouble, the configuration, all PLCs here. Now, what project you want to do? Okay, something similar to your system, like a mixer. Yes. Normally that is the mostly I use that project as a first project because in that project I will have all these functions. Okay. So okay, plan first. Let's say I have 10 like this. Then I have before that. Sorry. Okay, I'll show you how to do flowchart. First. How to create a flowchart for your projects. Okay, so flowchart. Okay, this one they call graph set, similar to your SFC program. Okay, yes, sequential function chart. So this one will have two symbols. This is the condition. This is the function. Okay, condition and function. Now, condition means like condition lah, now we open, now we close, sensor on, sensor input, push button, the motor feedback, everything. Your function is the control, whether the motor on or off, the valve open or close, right? Okay, the cylinder on or off. Okay. So I create a simple one. Let's say I create something like this. When I press start, the function is motor 1 on. That's all. Then let's say I want to off the motor after the timer. So means you need to on the timer as well. Right? So when I start motor on, at the same time I want to on the timer. So I put timer 10 seconds. So timer will give you an output, right? That is the timer dot the Q, the output. Okay. So from when the timer give you output, I want to use the output. I want to off motor 1 off and motor 2 on. Okay, then same like if I want to add another timer. Or if I want to stop, maybe no, I put another timer for this. So that's simple. Then another timer for this motor. Okay. Timer 2, 10 seconds. So when timer 2 output, motor 2 off. Okay. Then for stop button, okay, let's say I make it different. So when I press stop, motor 1 and motor 2 both off. Can see until here? See, yeah. So like this is my program. Now you see how I convert this into a logic. So when I start, so of course I normally open. Okay. I make it simple. I use a coil. So if you want to use separate also can, but try to use mix both. Some output is coil, some output is separate size. Maybe here also I say I do the same thing. For motor 1 I use coil, motor 2 I use set. So I start. Motor 1. Okay. That's all. That according to this, that's right. So this is when this one press motor on. Okay. Do I need to latch Yes, because when I start motor on, then after the timer only the motor off. Right. But this is a push button. So I need to do the holding, right? But you see, according to the flowchart, in the flowchart they won't tell you is it what to hold or not. What they tell you from the flowchart, that is when I press start, motor on. That's all. So we know, as a programmer, we know the start button is a push button. So when I press, of course the coil can on, but cannot latch. So I need to do this. The timer. Timer. And E, T, Q. This I just put the time value. So according to this, start on the timer, right? But now, according to this, start on the motor, the same start on the timer. Right? According to this, can the start button run the timer? Can, but if I press, the timer can run. If I release, the timer will reset. Because that is the function of the timer. The timer function here, when there is an input, I will start to count. If the input is off already, the value becomes 0. So of course I cannot use the start. So I use the motor. Okay. Then I need to create an output, right? So this output and they won't tell you me to play. What they will tell you is when the timer finish, motor 1 off, motor 2 off. So as a programmer, we know from here. So what I do, I create a memory, maybe a M1 off. This is the this one, right? So means motor 1 need to off. So how to off motor 1? M1 off. Now, same timer need to on motor 2. So let's say for this, put motor 2 and I test first. For this one, I need to latch on or not, I don't know. Because for this, maybe I can predict because this is the push button. But here we don't know because we don't know about the Q, how the Q works. So what happened? When I start motor on, motor run the timer. After the timer, Q on, right? So Q will off the motor. So what happened? Your this memory also will off. So means it will on and off. So it will on here and off. Right. So what happened? Motor 2 cannot hold. So I can latch or I use the set. Very simple. Okay. Then same. The same timer need to on the timer 2. But we know this memory is like pulse, right? On off. So this timer cannot on the timer 2. So what I do, I use the motor 2 to on the timer 2. So motor 2 on the timer 2 and 2 lang. So I didn't input the EN, enable the all line, right? I didn't put that. So PT. So now TS tag. Then this timer output need to off the motor. Now I have two ideas. One is create M2 off. Then this memory need to off the motor 2, right? But now I'm using set. So if I want to off, I need to use reset. So I have two options. That is, number one is this M2 off. Reset the motor 2. Or I can, this is another example, or I can straight away reset here. Same thing, right? Because the Q is represent this. Then I use here to off reset. So straight away I can use this here. Even here also, right? I can straight away use the motor 2 here. Also can. It's depend on you lah, how you want to do. Finish until you now stop button. When I stop, motor 1 off. Motor 1 out to off. Cut off the latching, right?
Yeah.
Stop. Okay. Then motor 2 out to off. Reset. So if I'm not doing this way, I'm doing this way, I add the stop here. Because when I press stop, motor off. If I do this way, then I put one stop, then bring the line after here, also can. Or I get one like this line. Just direct, stop and directly motor. So okay. You see like which one you prefer. There's no such thing like a long program or short program. It's good running. Make sure you understand the program can work, then that is it. So if the program is long, no problem. Later on we can modify. We can see which one we can modify, which one is not necessary. We can leave it like that. So okay, good. You want to take picture or something? You can take picture. Write down. Do the
Okay.
now I do the same thing. I draw the project line, and I do the flow chart as well. Because when you have a flow chart, like 70% of your program is done. The balance 20% is the latching, and test. It's working, some put some interlock, all that. Okay. Now, simple one. Let's say I have a pump. Let's say I have two valves here. Valve A, valve B, pump. Okay, so very simple. When I start, valve A on, so it will fill up to certain level. Then valve A will off, valve B will on, go up to certain level. Valve B off, then mixer on, mix after the timer, mixer off, pump on. So when pump on, it will go down. Once I reach certain level, the pump also off. Okay. So to the level, what I do is normally your system you have a level meter, right?
Yeah.
But here what I do, because level meter is that analog.
No.
We haven't learned analog yet. So what I do, I just put like a level, a floating switch down.
Oh.
A level switch, like a normally open, one switch here, okay, one switch here. Okay? So this is, I make it all normally open for easy programming. Okay? Then go there. Then this machine have a start, stop. Okay? Now, how it goes. When I start, it start to feel, right? Start to feel, okay, until reach the low level. So you need to know low level and high level, you manually need to on. So, because we don't have switches, right? So we will be using HMI, right? So what you do in the HMI, you will add the start button, stop button, right? At the same time, you add a low level and high level button also. But for these buttons, you will be using momentary. Correct? For this button, you use check. There's no momentary in there. Toggle. Use toggle. Toggle means you press one, it on, press again, it off. This one use momentary, right? Okay. So what you do? So you just imagine, okay, valve A on already. Just imagine already reached the low level. Just press the button. So means already reached the low level. Then from here to here, I want to set a timer. second, then only the valve A will off, valve B will off. Okay. Then valve B go up to high level. So press the high level. Then valve B off, mixer on. Okay. So mixer will run for 10 seconds. Then mixer off, pump on. Okay. So when pump on, we know the mixture inside, right, will go, decrease, right? So when decrease, what you do, you off the high level first. So just now you press on, right, you press again, you off. Okay. Then you wait for a few seconds, then you press the low level. So when the high level, low level both off already, your pump also will cut off. You don't care about this one line, okay? It just when low level, high level, low level off, okay, pump also off. We just assume this one is already clear, okay? So this is your project. Similar like just now, start, stop, but of course like I teach them. I don't normally, I won't see how good you are doing the logic everything. My idea is normally how familiar are you with the software. So you know how to use these functions lah, okay? The timer, the usage of timer is correct or not. That's what I see. Okay. Now first thing is the I/O. So input, we have a start, stop, LL, high level, right? What you do, because we don't have input, but still I want to do a variable. Of course, you need to do variable, right? So what we do, these variables, actually you don't need to create memory also. Right? You can leave it local variable, but I want to create variable for this, like a practice lah. Okay. Then this is the M0, M1, M2, M3. Because we can't use the I. Okay, because we don't have the stop. Then output this one we put starting from M10, M11, M12, M13. So this 8 you give memory. Other than this, anything you needed, don't put memory. Just make it like a local variable or internal variable. Now we do the flowchart. So since when I press start, we don't make it complicated, we make it simple. I start, valve A on. That's all. Finish. Then so valve A on, start to fill, so low level will on, right? So when low level on, okay, for start I don't put on or off because it's a push button, means that push. So when low level on, okay, I want to on a timer. So I put timer VA 10 seconds. Okay. If the timer is too small, you cannot see, you cannot observe, you put bigger timers. So when timer VA done, finish the timing, then the valve A will off, right? Valve A off, valve B on. Okay, off. Then the level go to high level. So when high level is on, VB off, mixer on. Okay, VB off, mixer on. At the same time, I on a timer for mixer 10 seconds. So when the timer mixer done, finish, then the mixer will off, off, pump. So when the pump on means go down, right? So it means when the high level and the low level both off ready, because here on, right? On. So here off. Pump also. Finish. Then this is one cycle lah. Then again I start continue lah. Okay. So for stop button I make it a separate flow. When you press stop, all off. Like emergency stop lah. Okay. Means valve A, valve B, mixer, pump. All off. Now. So your configuration is done, right? So before you start, record that. Then you do the variables. So all these will be the e-bull. The others other than this become normal boolean. So other than this is depend on you. You want to create a variable, then you want to use in the program, or straight away in the program you just put one name, you can create. So in the maybe you can do both. One maybe you create in the variable then you use, maybe another one maybe you can use in the program. Okay. And when you want to do this, don't create everything then test. No, sorry. Create one by one you test. Make it easier. Okay, start valve A on until here. You add the stop button for valve A. Test and see. Start. At the same time, you want to do the HMI also can simultaneously. Or yeah, you can create the variables. First time all the variable create. You export, import, create HMI. Also can. Okay. Then you start to do programming. So but maybe you can create just for the create all the variables, export first, then just click start valve A on, then stop. Because you need to download the project. Because why? When you download the project, your variable also will be downloaded. So then only the HMI can access. If no, then there will be an error. Okay. If the thing is the HMI is assessing your variable, not your logic. Means if you didn't do the valve B mixer pump, no problem. Because it will only assess your variable. If the variable 10, I change color. Let's say you didn't do the programming for valve B, no problem. HMI only this because it's a button, right? Easy to test. Once done, okay, test. All okay, good. Then continue. Okay. When low level on, timer, after the timer, valve A off. Stop until you download. You press the start in the HMI. Start the okay. Then valve B on, when high level, valve B off. Okay. So valve B at the same time you add the stop button also. Means valve B must off when high level or stop button also must off. Then continue. Mixer on, timer, after the timer mixer off. Same for mixer also add the stop. Then pump. Slowly one by one. Okay, good. Any question here? Okay, yeah. Any question? You can ask. Okay. Alright. Okay. Want to make a coffee or tea? You can make a coffee or tea. You can bring yours. recording?
Yeah. Okay.
Not very sure. It is like record one by one. Do I have my coffee?
Okay.
The temperature is okay?
Sorry?
Temperature is okay?
Okay. Yeah.
Is it cold means that I mean, because I'm sitting there, I won't feel the cold.
It's okay.
But here it's just cold.
Yeah.
machinable equipment, yes.
Just a line lah.
Yes, sir. Yes. Okay, the valve A. Okay, no. Because the valve A, right, because using normal coil, right? So if you stop like this only, just cut out like this only. You go down, you cannot do like this for valve A. For valve B, yes, you can do like this but reset. If you want to off, yes. You take the R like this. The valve A can be, yes. The valve A can be. Then the R will make it bring up.
So valve A, how to
Stop.
yeah.
You already stopped the one. You go up. The stop is there, yeah.
Oh yeah. basically for the high level and low level of that one should be in normally open close.
It depends where you want to how you want to put. Because it can be normally open, normally closed also. In this case, must put normally open, not negative false memory.
Normally open. So if it is 1,
If it is 1, then it allow you to on the pump. When it's 0, I will cut off. But it must be in branch. Have you tested this program already?
I have problem here.
Okay. Then it must be normally open. Yes.
Branch meaning
Below.
oh,
Okay, now I will put normally open first. One is normally open. Below, yes. Okay. Then here high level. Then you see this is a pulse, right? Pulse cannot on the pump. Just can give a pulse signal. Correct? So if you want to continuously on, so you latch it. Latch the pump. 0 because it's a push button, right? The valve off already. So need to latch. Yes. The rest I think okay. Go up. One, off, okay, off, insert off ready. Pump on, right? Okay. Now low level off. Okay, go up. You see anything on? No, right? Sorry, high level should off first, sorry. Go down. Okay, you off the high level. We try again. Okay. Go up. Okay, you try again. Start. On. Off back. So when you stop, it will off lah. Right? You need to press off. Okay. Now low level on.
On for 10 seconds.
Then it's off. Okay. Now high level off. Okay, go up. Off is on. Can you see valve B on back? Kan? Yeah, you see here valve B on back. Okay, why? Because you see the moment high level off, because your valve A off, still on. Okay, so we troubleshoot. So this valve A off is from where? From here. Okay, this one is from where? From the timer. Okay, so how to off the Q? If the input off, the output will off. Correct. Okay, but the input is low level, but so you can off the low level. Correct. But I can off the line. Correct. I cannot off the what they call Q is the memory, right? What VA off lah, right? Okay. I cannot off the LN, but I can off the line. So I put some interlock here, right? Normally open or normally closed, that depend on the interlock. So I can off the line. Correct. Okay. Now that is number one. Number two is, okay, why I need this timer? This timer is for what?
To turn off the
Turn off the valve A, turn on the valve B, right? Okay. So after valve A off, I don't need the timer already. Right? So I can put a valve A as an interlock. It means earlier in front, I mean on top here is start VA less than VA after 10 seconds VA off, right? So it means I can't remember, I'm confused. So when I press start, the valve A on, the current just goes to this. So here also, the moment low level on, so it will done. Then after that the Q will on, energize this one will off, right? When this one off the valve A, and here also off. After that, this one also off. So this one become like on and off. Correct, this memory, right? This variable. So to set the valve B, this one is like on off is enough, but correct, to set, because it's a set, right? So I just on off enough. So I can put the interlock here, or I can make this as a pulse also can. One time. So that's the many way lah. So that is the logic lah. Okay, create many type of different way of logic. Most important thing is we need to know how to use the timer, how to use this one. Okay, good. Okay, now you off the low level. Then you modify. First off. Now you try to modify this one. You need to move here. Yes. Okay. Then you add a normally open. I mean, put normally open valve A also can. Normally close pump also can actually. Yes. Because the moment the pump right here, the last round, right? Pump, this is the timer mixer, right? LL, HL, the pump, right? The moment pump on, what I put this up. So what happened? It will cut off. So the LL still on, but here cut off already. So means this one off already. So high level off, nothing to do. When low level off, barulah pump off. So barulah dia boleh normally terus can connect. But that's many ways. Your start button need to off. Letak dia keep on running. Okay, WAF B is on. So now you see the line is not on. Tadi dia on kan? But now not on. But your WAF B is on because you're using pulse, set, right? So because this one giving a pulse lah. Kalau kita guna set, you use a coil also can, but need to latch. Okay, now you on the high level. Save first. You're done, you save first. Okay. My idea is not. You saved it, right?
Yes.
Okay. So my idea is not to see the logic. My idea is you familiar with the software. So now you know how to do online editing. And when you're online, you can edit, and not necessarily must offline. It's about every time you offline, edit and download, the PLC will go to stop mode. Stop and run. So what happens with the stop? With the stop, all your output will cut off. So it will affect your system. Because we just want to change only one. Normally we put on it to tambah something right now. So no need to offline. So can connect, then just do the changes. Very straightforward. Right? Okay, that is number one. Number two is the variables. How to create variables. Okay, you go to variables. How to see variables. So you see, this one all you use the memory. Valve off, not using memory. So not necessary actually. Okay. So this one all, if kalau actual, we will be using the I lah. I, rack number, slot number, input number. So output also. Okay. So most important thing, we need to know how to create the variables and need to choose the correct addressing. Okay, this is a internal variable, so not necessary because it will be running inside the PLC only. Okay. Alright. Next, the Ethernet. We need to know how to create the Ethernet settings, everything. What to choose here. Okay, why we need to choose? Okay, because of what the CPU we using. Once done, we go up. In the Ethernet here, we need to choose the Ethernet. Then only I can access the PLC using the Ethernet, using this one. Okay, that is number two. Then, how to create a simple program. That is my main idea. Okay, good. Alright. Any question?
Alright, but I try to integrate with HMI, but here it doesn't show like this here in this software.
Start, stop, low level, high level. Okay, go to low level. What type of low level you using? Double click. Toggle. Okay. So you go to double level. Yes. Because this looks like a previous program. I think you need to do the start, stop, right?
I've done it.
Oh, okay, let me see. close this. Okay, go to home, system parameter, 5, this one, right? Okay, double click here. So 10, 20, 24, 502, right? All okay. Okay. Right. Then import next, so import, right?
Yeah, but
Okay. Why? Okay, go to project. Online simulation. Try online simulation.
yes.
Save. Only 2 is showing. You save first. Save. Yeah. Okay, now online simulation. Okay, stop first. This 2 double click. Click here, tag. Maybe you import again the text.
This one also not showing the
Yeah, output not showing because output not showing means it's some communication problem. Okay.
sorry, import again.
But okay, before that we go to your program. Go to internet. 10, 20, 24, 5, 0. Okay. Go up. Internet here. Go to go offline, you export and import again. Okay, import already. Okay, now try to save download. So 10/20/24, 502. Okay. Then okay. Import tax same, right?
Yeah. You delete everything.
Yeah. Let's copy paste lah later.
Copy this one.
I just delete. Once down, okay. Just put one line here. One line. Okay. This arm or what here. Okay. Click it. Download this. Project camera. What is the details of this project? Few problems, then your PLC, go to PLC. What problem? Okay, go this one. It's already disconnected, right? Set address. Using USB. You try to use the internet. Just connect. Okay. Okay. Right. Connect. And connect, right? The variables. So energy variable, right?
Yeah.
Go down, go to
The export is from here or the energy variables?
on the variables, yeah. You export that, right? Okay, you go to HMI. And it close. You go to file new project. Right. do simulation first. Try simulation. Stop first. See tomorrow what is the issue. Compare dengan tadi punya project. You save this one. Whenever you done, you just save first. This one. I think under HMI value.
HMI variable is
Tak apa, no problem. Okay, export. Now, okay, your folder. It's already your folder. Save. Ya, maksudnya ambil masih sebab 1 hour lebih, 1 hour plus dulu.
device now respond immediate
No
respond
communications.
from PLC.
Some communication issues, some settings. You've done your save first. And you can continue to work.
So tomorrow what will be
Yeah, we learn other functions, counter compare functions, compare move function and everything. Then we try with this one. Mode pass, how to do the mode pass. Try to enable the mode pass using the other file. Yes.
then I left this
Okay,
here.
sure, no problem.
since I don't have the ID of module, can we like control it via this? Because tomorrow we will be communicating.
Yeah, we try to communicate. If
And
we
this
can
one will-
communicate, then here we can
Do wiring,
connect
some
to
wiring.
the wiring, then we can connect.
You also familiar with SCADA bukan? Schneider bukan?
Yeah, but do you have the software?
Currently we are still in progress to
Use the
SCADA.
SCADA.
Yeah. Right now we still use the Tomcapi French software.
So it's also SCADA.
So SCADA. Yeah. One is old school, like 1990 something
Oh,
French software. So
yeah. However, not familiar, but I have seen before lah. Because one of my participants last time come and learn Siemens, but as SCADA they use Aveva. So it's a similar thing what you do there. But Aveva software, you need to add what PLC you want to communicate first. Number two, like this, you need to import the tag. So I think if Aveva, I think you can import from the file. No need to export. Like a video designer, it will retrieve from the file, right? From the whole file. Aveva also the same.
it's semi-environment.
Then after that, the same thing like you do HMI. Actually, SCADA is a similar thing like HMI. Only thing is SCADA is like more functions lah, more settings. Can do a lot of things in SCADA. That's all. Because SCADA software is all working license.
Yeah.
That's the problem. I have SCADA for Siemens. Yes. Siemens one I have the license. Other than that,
Okay, so thank you for today.
okay.
See you tomorrow.
Yes. We need to book the flight, is it?
Sorry?
To book the flight.
Yeah. Peak hour right now.
1 year only lah.
10 minutes.
Yeah. The only thing is for now you go the flyover to Parallel Mall beach and less than 10 minutes from here.
Okay.
Okay, see you soon.